Hi everyone, welcome back to C# on a SQL Server Virtual Conference, Day 2, second half. Thank you so much whoever has tuned us today, and this is the last section of this 2 days virtual conference. It has been really exciting, 1.5 days, and I'm really excited for this second half because the very first session that we are going to do is on rocket scientist perspective on index column selection. I mean, how often you get to hear that session title and how often people actually talk about these kind of sessions. I'm really excited and looking forward for this session by our next speaker, Mike. So let's go ahead and get him on the conference. Hi, Mike. Welcome to the SQL Server Virtual Conference.
Thank you. I enjoy being here.
Thank you. Thank you so much for your time, Mike. I know it's weekend and it's time when you spend at your home, but we really appreciate you on joining on this weekend. We're really looking forward for your session. And as we're talking behind the scenes, I do know you have a lot to cover. So I'll just let you go. I'll add your screen into the stream. And next 45 minutes is all yours.
Okay, thank you much. Good morning, good afternoon, good evening, wherever you are in this world. I'm glad to be here and give you some my insight on how to work with indexes. That's what we're going to talk about today. All right. Okay. I don't quite live in Austin. I live about 75 miles to the west-northwest of Austin in Texas. I speak Texan, so I hope y'all understand me, and I have a lot to cover today, so I'll speak fast, even for a Texan. And I live in a little village called Sunrise Beach, and you can see it's aptly named in the picture there. There's my contact information, and we'll get back to that later. What I really want to do is talk about, I don't have some of the three-letter acronyms that a lot of people do. I'm not an MVP. I'm not retired yet. I did get, when I was in Air Force, Lieutenant Colonel, so there's my LTC. But in reality, I have a four-letter acronym, GEEK, and that's usually with what I talk about myself, and you'll see how geeky I get in this presentation. So in former times, as I said in the intro, a rocket scientist, I was an Air Force fighter pilot and test pilot. I freelanced for PC Magazine for a few years. I was a CTO for an insurance company for 9 years, got a new boss. Shortly thereafter, he asked me to part company, which I was really unhappy about. However, one of my contractors gave me a call and said, Mike, could you work for 2 days? Ended up being 2 years. It got me back on the technical side of it. I love SQL Server. You wouldn't believe how much I do it, especially the performance tuning part of it. And so ever since then, I've been working in SQL Server since 6.0. I'm right now a part-time database consultant and trainer. I used to blog on logicalread.com, and now occasionally with Steve Jones on SQLServerCentral.com. My goal in life is just to dig deeper into optimize your black box and figure out how it works. So was I really a rocket scientist? I'm not going to go through all that, but people have asked me that in the past. So if you look at that, the credentials there, I think you'd probably say I do qualify. The picture in the lower right hand is a rocket motor when I was at Purdue getting my master's degree, and obviously not a flyable motor, but it was testing performance characteristics of propellants at unusual scenarios. And basically, I'm just a geek from day one on. Today, the presentation, T-SQL demos, index utilities, and database backup files can be downloaded at that site there. And again, it's tinyurl.com, rocket indexes. You may need to map the drive letters for the DB restore. However, I think if you just once you get that written down or taken a picture of it, if you just listen and then later on review the slides and scripts on your own time, I think you'll get a lot out of this presentation. At least I hope you do. There's the Dropbox location, the The one script I'm going to be going over primarily is cover and index column order.sql, but you can see there's a PowerPoint presentation. There's a backup of VentureWorks 2017 Big. I'll talk about that in a second. There's a way script to create the big version of the two tables from VentureWorks 2017. And then there's some missing index utilities that I'm not going to talk about today, but they're very applicable for working with indexes. So just as an overview, think about how do you create indexes? Do you take the index wizard recommendations? Do you really look at column selectivity and ordering? Do you consider duplicate and near duplicate indexes? How do you know you made the right selection? Do you just define one column? And what about other columns? Do you put them in the index definition? Do you put them in include clause? Are you concerned about the width of those columns? Because the width can make a difference in the size of the index. We're going to talk about some of this in the next 50 minutes or so. And so with that, let's get started. This can be a lot of material. I don't have enough time to talk about it. I could talk about this for 3 hours and still not repeat myself. So again, listen, download the scripts, try them on your own. You get much more out of this with the secondary, tertiary review. So let's look at the script cover and index column order.sql. But first, let me switch screens here. Here's the script to create the VentureWorks Big, and all this script does is create two tables. It creates a sales order header big and a sales order detail big. And so sales order header in the original database was about 31,000 rows. Now it jumps it up to 1.3 million rows. Sales order detail was 121,000 rows, jumps it up to just under 500,000 rows. I have another script that I run that gives capacity of the and shows the size of the indexes, and you'll see that in some of the review columns. Okay, so let's get started. I always start whenever I go to a new client or anything, say, well, what version am I running? You can see I'm running 2019, the latest C cumulative 18.8, and I'm developer version on my own box. And then I also messages. I've also done it. So I have a clean version of VentureWorks 2017 Big. I've already restored it. And so if we go over here and look, and you look at VentureWorks 2017 Big, it has two new tables. It has sales order header big, and it also has sales order detail big. But if we look at sales order header, if we look at the indexes, these are the same indexes that come with VentureWorks 2017 sales order big. Anyway, so those are the indexes. With that, let's get started with a query. So, and let's see, I have everything turned on. So all this is a select statement from sales order header big. Remember, that's about 1.3 million rows or so. Sales order ID, revision number, territory ID, modified date, where territory ID is greater than and a territory ID and status is equal to some value status, which you can see is defined above. In this particular database, any territory ID is greater than 5 or non-US. So this is a very simplistic query. I run it twice just so that I can get rid of the fiscal IOs. And if we look at the execution plan, if we come back over to messages, you can see there was one fiscal read, but in the second version I ran it, there's 0 fiscal reads. So let's go back to the query plan. You can see a suggested index is there. We'll talk about that in a second. And you can see, let me bring it up into the picture. Come on, stay. It's a clustered index scan. And then you can see there that there's a predicate. The predicate is on territory ID and then on status. Let's talk about predicate, because sometimes you'll see a predicate, sometimes you'll see a seek predicate, sometimes you'll see both, all of the above. The seek predicate takes advantage of the ordering of the data that's in your B tree for your index. The predicate then, after that result set, then the predicate filters it further with, in this case, it's by the territory ID greater than at territory ID and the status greater or equal to at status. So in this query, we have an equal and we have a greater than. And so let's come down and look at some of the numbers. We come over here and look at the cost. It's 22.25, and it took roughly had 29,295 reads, and it took roughly 297 seconds. Well, it varies on my computer, depending on what else is running on my computer with that. So there's a difference there. But okay, so we looked at, and we have the values there. So let's go back and let's run the missing index. Now, I tend to, when I write indexes, I like to have usually IX underscore the table name and then the various columns that are in the index definition, not in the include clause. So in this case, we have status and territory ID, it's in the name, and then we include the revision number and modified date. And this is a cover and index, and that's all we're going to work with today, primarily is cover and indexes. And so if we run that, and then we run the capacity check, you can see that indexes don't come free. You're paying about 26 meg for this space for that additional index. And if you notice in my slide or up there, I had data compression equal to row. If you don't have data compression equal to row, if it's equal to none, it's about 30 meg versus 26 meg. So there is a savings in row compression. I use it everywhere, as Monica said yesterday. So let's run now the query again, same query, and look at the execution plan. Now we get an index seek. And now you can see it's a seek predicate. There is no predicate. And it took advantage. Notice it put scalar or status first, and then it put the territory ID second, even though the where clause had them. If you look up here, the where clause had territory ID first. And that's a reason for selectivity. And if we come down and look then, instead of so now we're down, instead of an index cost of we had earlier 25, now we're down to 0.26. And if you look, we also had 264 or 5 reads. Again, it depends on where you start and mix extend. And this number will vary a little bit as you run the same scripts. But anyway, it's significantly less than 29,000 logical reads we had earlier. And then you can see it took 110 seconds. So running slower. I think the streaming software is causing some of my queries to run a little bit slower than anything. So what happens if we change the non-clustered index and do territory ID first, followed by status? And before we do that, I want to switch back over. No, I don't have that. Okay, so switch back over, and if we look at the table, you can see that if we organize it and do a select by the status, territory ID, and modified date, it comes down and you have status of 5, and then the second column, territory ID, is the status of greater than 5. So if you go greater than 5, then it can the predicate seek or seek predicate can go directly to the lines in the index. They don't have to worry about it. I don't know if that's real clear, but if I use these type of tools to help me visualize the data so that I can, the queries like this, visualize the data so I can see what's going on and try to understand what the optimizer is doing. So let's come back over to here and let's see, did we run this? We'll run it again if we didn't. Okay, and now you can see that the size of the index is roughly the same. And again, about 5 more meg to if you don't have the row compress. And we run it again and we look at the execution plan. We still have index seek, but now we have a seek predicate based on territory ID because that was the first column, and then the predicate is on status. So the data is not organized in a greater than, with that greater than that we have for territory ID. It's not organized so that it can actually take advantage of status in the B tree, even though status is included in the B tree as your second column. So I hope this is starting to make sense, but now we're instead of 0.2, we have a 1.14 for query cost. And instead of that small number of logical reads, we're now back up to 2024, and it took 250 milliseconds. So let's go back and say, well, what happens if we have status as our first column? Because we've already seen that's what's suggested, and territory ID is in the include clause. So we'll drop that. And again, it's still, the index is around 26 meg. And now if we run the query again, same queries we've been running all along, we get an execution plan. It's still an index seek, but we still have a seek predicate on the status, and then we have a predicate on territory ID. And with a cost, query cost, 0.4, that's about double what we had with the recommended index. And then also 425 reads. You can see that's a lot less than we had from when we had territory ID first, and 109 milliseconds. So if we go back and let's drop this, and we go back and just look at a summary of what we just looked at. I'll tab. And this is again showing status and territory ID and showing how the data is organized. So we first, in the optimizer, since it used to seek predicate on the recommended index, it went to status of 5, goes all the way down to find something greater than 5. And you can see there how it's organized. And then if we look at what we were trying to do, you can see the 22.5, the recommended index is 0.265. When we had territory ID first, it was 1.4, but when we had status first and then territory ID and include clause, slightly more in query cost, and again, almost not quite double, but double in the number of logical reads. So what do you gain by putting territory ID and include clause? Well, you gain a little bit of space in your root and your intermediate levels of your index, because territory ID is still stored down at your index page level. So that's query 1. Let's go back. Let's go to scenario 1. Let's go back to there. And I did drop that, didn't I? I love the new version of when if exists. That really is nice. Unfortunately, half my clients are still in 2012. Okay, so here we have another query where we've added in a third column. And we have essentially almost the same query, which before sales order ID, revision number, territory ID, modified date. And then we have modified date greater than or equal to start date, modified date less than end date, status equal to at status, and territory ID equal to at territory ID. And we'll run this 5 twice again just to make sure that we don't have any physical reads. And we come down and we look at the execution plan and execution plan for this. So we have a clustered index scan. So we're probably going to have about 29,000 pages scanned there in the logical reads. And let's go and check that. See, and sure enough, there's 29,295. Took about 265 seconds. And we come back over here and we have a query cost of 22.38. And we look over here and we have just a predicate. Now the predicate has modified date, and then it has territory ID, and then lastly, our status, and then it's checking on territory ID at the end. Essentially the same order as we had up here in the where clause. So just right now, I hope you're starting to see that the where clause usually defines the columns you probably want in defining your index, and then anything else like in your select part of the clause, anything that's not included in the where clause, then that probably needs to be in the include clause. Think along those lines. So it's not absolutely all the time true, but it is true for a lot of cases. Again, we had a cost of 22, which is roughly what we had before. And we still had that big logical reads where we scan the whole table. Okay, so now, again, it has a recommended index. And this is a strange, the optimizer came up with a strange result here. And again, you can see it's about 26 meg in size. And now if we run that same query we just ran earlier, and we have now an execution plan where we have the index seek. And we have a cost of 0.088. This is not the one with the strange one. it's the third scenario that has a strange one. So we really dropped down. So we had 0.088. We're at 22. We only have 4 logical reads. Sometimes it's 5. Yeah, it depends on where the index starts in the mixed extent. And then execution time of 0. So just for fun, again, we come up here, and now let's go back and look at our execution plan. We have the seek predicate is based on territory ID and then or status, and then the territory ID, and then the modified date. With the modified date also, so everything was covered by the seek in this particular case, by the seek predicate. If we come back over here and just for fun, now let's reverse status and a territory ID just to see what happens. And if we run the same query over again, I'll show you all the results in a table at the very end of this. And now we have index seek again. And now the territory ID and the status are reversed, but it's still essentially the same index we're doing because they were equal in this case, not that we didn't have a greater than. It didn't matter which one came first, and we still have a cost in about 0.088. And in this case, that we had the 5 logical reads. So we can deduce a lot of things from this, that if you have equalities, it doesn't matter which one comes first in the where clause or in your index. But if you start to have not equals or greater than or equals or less than and equal or less than's, then it may make a difference in the order. So let's do a little cleanup, and then let's go back and relook at the results again. And we switch back. Okay, this is the scenario 2, and we have our data. And so we started off with the clustered index scan where we had 22.088, and regardless of whether territory came first or status came first, we had roughly the same logical reads, same performance, and the same number of rows returned. So going back, we're running good time. I guess I'm talking too fast. Okay, so let's look at a different query now. Okay, this one is roughly the same as before, except remember in before I had territory ID equal to @territory ID. And this one, it's now territory ID is not equal to territory ID. We'll run it twice to make sure we shouldn't have any physical reads, but I'm not going to chance it. Execution plan, we come down. We have a suggested index. We have a cost, and it's 22.4, roughly what we had before. And now we have no seek predicate, but we have a predicate that's based on modified date and status and territory ID. And notice the status is switched up front, but that's what it was here. Same order as what's in the where clause. And the optimizer doesn't seem to really care when it's doing the filtering. It just does it. So again, we had 29,295 reads. Again, is scanning every row, all the pages, and then we had the clustered index or the predicate, no seek predicate. Now, the recommended index, if you come back over here, if you look at it, it's based on status, territory ID, and modified date, and it includes revision number. And why don't we have sales order ID? Because that's part of the clustered index, and the clustered index is automatically included in any index definition. So let's not worry about that. Let's come back over now, and did I create it yet or not? I don't remember. Let's try it. And again, you can see it's roughly the same size as before. They're all about 26 meg. Now let's rerun the first query again. This is the one that I thought was kind of interesting, and I don't have a good excuse for why it comes out this way. And there's the execution plan. You're going, wait a minute, what happened? We have the index seek on the non-clustered index, or the one we just created, but it's joined to all this stuff over here that doesn't appear to have any connection with the table. And this puzzled me for a long time. Okay, so we have the clustered index seek. We look and it has a seek predicate. Notice though it pushes modified date out to the predicate, and in the seek predicate we're on status and territory ID. So what's going on here? It's not quite what I expected. And so we have a query 0.308. And if we look at, we had 2 scans going, well, where did the second scan come from? But we're down to 378. So the logical reads are a lot less, and it took about 15 milliseconds. So the big question is, why did the optimizer come back up here and look? The optimizer, it recommended status and then territory ID, but let's go through and redo the query, and let's put the status and then the modified date, then the territory ID. And I do have a reason in the back of my mind for doing this. So let's just run that. And now the same query again. And we look at the execution plan and going, wait a minute, what happened to all that junk we had in the previous one that Microsoft recommended over the Mike Byrd recommended one? And you can see now the query cost is down to 0.2, so it's a little bit about half of the original. And if we come over here and look at it, we have seek predicates. In the predicate, we're on the territory ID, and the seek predicate, we have status and then modified date. So why is that? Well, if you look at the index and the way it's ordered, and I have a query over here where I ran it, is that it can, using the B tree, then the seek predicate, it can go straight to a status of 5. And then since we had not equal to 5, then it goes everything above it and everything below it. And that then, if the third item is modified date, the third item then would be the dates sorted in the third order, which then means it has to do a complete seek through all that, and that's where you get or scan through all that, and that's where you get the predicate. But if the modified date is second, then for a status of 5, the dates are all in order for a status of 5, and then it can do a scan on the territory ID. That's what caused this one to be better. And I hope that makes sense. So we got it. And if we come back over here, we can see we had 24 logical reads and execution time of 0, which 0 doesn't mean really 0. So now, and notice we had both indexes active at that time, but it still took the modified date, status modified date. Go back to here. If you look at that, look at the object, it's this status modified date and then territory ID, which is the one we did. So let's drop that and let's just look and see what happens if we put modified date first in front of status, just to see what's going on and see again. And again, this is the geeky part of me going, wow, why does Mike do all these crazy indexes? Because I just want to see what's going on. So now it goes back and gives the recommended index, which, if you remember, the recommended index was not the right index. The right index is the one where modified date comes before territory ID. And we're back to, okay, so this was an index seek, and you can see under the seek predicate that the modified date is there, but then the predicate has both the status and the territory ID of that. And that's because the things aren't ordered behind modified date correctly, or correctly as far as the B tree goes. So, oh gosh, does this make sense so far? I hope. And you can see that it was still around 26 meg. So I did one more query. I wanted to see what happened if we know that if we make a query that's on status modified date, and remember the one we had before, I had territory ID up here, but I said, what happens if we push the territory ID down to the include clause? And so let's do that. And let's rerun the same query one more time. And we get up here, and lo and behold, it's the query cost is, again, 0.2 roughly. And we have the seek predicates down below and the predicate of territory ID up above. So going back to looking at the table for scenario 3, go away. We're going up, we can see that for the first one, we have this clustered index scan. And then for the second one, we had the recommended index, which wasn't good. But then if you look at the third one, which I used the Mike Byrd index, is 0.95. And then lastly, and I can't get the screen to come up. Let's go back. And lastly, essentially the performance was the same down here as it was for the second one. So in this particular case, it didn't matter where the territory ID was in the index column definition or in the include clause, because it was used both times in the predicate, not the seek predicate. So switching back. Let's change gears. And let's take a case where I don't need to restore it because we're back to pretty much normal. And let's look at a case where we have a single table query with a join to another query. So we're going to join from sales order header to sales order detail big. And then we're also going to join to production big. And so if we run this query, we're going to get execution plan. You can see it's asking for index. And if we look over here on the sales order header big, you can see it's doing a clustered index scan. And that's what, and if we come down, you can see it's doing an index, non-clustered index on sales order detail big, and it's doing it on the product ID. However, if you come a little bit further down, it's doing a key lookup. And key lookup to me is a sign that maybe I might be able to prove the query a little bit more. And then product is joined up here, and it's a clustered index scan on it with a seek predicate. So that ends up with an overall cost of 48, about double what we had before. And if we look at the, we have almost 13,000 reads on sales order detail big. We have our standard 29.295 logical reads on the sales order header big, and we have 2 logical reads on there with a time of roughly 600 milliseconds. So we go, okay, so normally, as I said before, when I look at an execution plan and I see a key lookup, I look to see, well, how many things is it asking for? And in this particular case, it's only asking for unit price extra over and above. So that, which means that in this index here, if it had unit price, it wouldn't have had a key lookup. So why don't we look at what would happen if we added unit price to the product ID under sales order detail? But we're not going to do that right now. Let's just go ahead and run the suggested index that they had suggested. And if we run that and then we run the same query over again, and then look at that. Well, we dropped the query cost almost in half, not quite. And if we look at over here, for sales order header big. Now we dropped it down to 40 reads. We still have 13,000 reads on sales order detail, and we still have the 2 logical reads on product. And the CPU time dropped down to 31 milliseconds. So it really helped taking out that roughly almost 30,000 logical reads on sales order header big. But what happens then if we go back and redefine the on sales order detail big product ID, and now we create a product ID, but we include the unit price. In other words, we're going to try to make the product ID cover this particular query. So if we run that, and then we run again, I just like virtual presentations because I can't see if y'all are awake or asleep or not. That's one thing that really bugs me about this. Now, the unit cost is now down to about 1.06. And if we look at the logical reads, we dropped sales order header big is down 37. Sales order detail big, remember, was a big number up in the thousands, and now it's 432. And CPU time is 31 milliseconds. So that's all defined here. So the question again is what columns to include when? To me, when I go back and look at a where clause, those are the columns that I consider for each of the items for each table that maybe should be in the index definition. And if not in the index definition, maybe in the include clause within that extension. All right, we've learned a lot here, but I don't know if you've really learned a lot because it's overwhelming how much information I'm giving you so fast. I strongly recommend you download the scripts and you try running it on your own. Okay, I'm going to skip over some things just from a time point of view, and we're going to go down here and look at an item completely different what we've been talking about. So let's look at covered indexes for update statements. So I'm going to create a new database called index test. And in that test, I'm going to create a sales order detail, and I'm going to insert all the data that's in sales order detail into it. Okay, and so then let's just do a simple collect from sales order detail and under this, and you notice I'm up here in index test now, and execute it. And it's a clustered index scan. So we can look at, just looking at this, what we probably want is a non-clustered covered index. It's on modified date, and that includes carrier tracking number, order quantity, and product ID. So let's do that. And if we do that, to cover, and then we go back and run the query again, we drop the query cost by a factor of 20, and you can see it's an index C. Okay, so we have this particular non-clustered index defined. So what happens if we go back and look at an update statement? And rather than, when I'm doing demos, I'll let you use begin transaction and roll it back after I'm through looking at the information. So that the information in the table doesn't really change going forward. So if we run this, all you can see is an update where I'm setting the order quantity multiplying by 2, and I'm adding 1 to the carrier tracking number. Look at the execution plan. I get, whoa, what is this over here? I get an index seek on the index I just created on IX sales order detail _ modified date. And you say, well, wait a minute, why is it using that index? Frequently I see a clustered index scan when I'm doing the updates. Well, in this particular case, because all the information up here in this update statement, order quantity, carrier tracking number, modified date, is in carrier tracking number, modified product ID, modified date is all in the index already. So, and notice the cost here is 1.2. Wow. As before, it was 1.04. No, that's not right. Anyway, so let's roll back the transaction. And now let's do a similar where I'm going to add an additional column that's not in the database, and that's unit price. And so if we begin this update statement here, okay, we get the clustered index scan like I thought we would. And why do we get it? We get it because unit price is not in the index definition. Let's roll that back. And if we just comment this out right there, try it again. Oh, I gotta also put a dash there. Try it again. And we look at the execution plan. We're back to our index seek again. So covered indexes can help performance by a considerable amount. So if you run a big update statement, you might want to look at it. And so you say, well, why does it need to either do the cluster index scan or the index seek? And it's because when you're in the transaction logs, so that you can do the rollback, you need the old data as well as the new data. And that's why it works here. So let's clean up again, and let's go to our last example. And boy, my time is working out nicely, a lot better than I thought it was going to be. I don't need to do the big again here, but I mean, and I don't think I have these indexes in existence. Okay, so let's run another query. And before I go any further, I got to go back and give credit to Penal Davey. He writes some unbelievable neat articles, blogs, and I got this from him. And so I'll admit that this is not Mike Byrd's thing, but it has a issue with the index or the optimizer that we saw up above. And so let's go back and, okay, so we run this and we run the select statement and we look at the execution plan. And you look at all this and you're going, well, what is all this table school aggregate, because you're asking for up here in the query, you're asking for an average. So I expected the average. You have the scalars, you have the lazy pool, you have inner joins. And anyway, this is not like the query plan I would have expected to get. So pardon me, it just takes me a long time to sometimes get that. You get a query cost that's up around 2.5 or so. And you look at there and you have on sales order detail, you have 1248. But look at all these extra reads and that's a lot of reads. In fact, that many reads is roughly 10 megabytes for this particular table. And you go, wow, what happened here? This is not it. So let's create a covered index. And it's easy to figure out a covered index. Okay, so we're coming out of sales order detail table. So this is already part or the included in the clustered index, order quantity, product ID. And so let's come down here and let's have one on sales order ID, product ID, and we include sales order detail ID and the order. Probably didn't need to include this one, but so let's create that. Run the same query again. And now we get an execution plan that doesn't have all that extra stuff in it. We still have a sales order detail, and then we're hitting it with the non-clustered index, and we have an index scan on sales order detail, and that's because of the aggregate there and trying to find the average. So that's expected. And look at our query cost now is down to 1.14. And if we look here, we only had 614 logical reads, so a lot less in time. And you can see my answers there. So let's go back and just say you have another select query that you generate just an arbitrary another index on. And it's almost the same as before, but it's not. It's on product ID first. And we run the query again. And notice my title has second try there. And we run it again. And again, this is something that LDV has done. And we're back to all that CRUD that we had in the first query before we added our first index. If you turn it off, let's drop the index, the second index, try again, and rerun the same query again, you get good answers. We're back to what we expect to get. So what is this telling us? Well, if you have indexes that aren't used, they could be hurting performance. Not only are they hurting performance from a maintenance point of view, they can hurt performance from a query point of view. Why the optimizer? Notice that the second index is not used anywhere in the query. You go back up here and recreate it again. Second try. And we come back and look at the execution. Oh, and then we run the query again. We got 5 minutes, I think, but I think that's enough time to finish up. We have all this stuff here, but if you look, it's a clustered index scan and it's on first try. We come down here and it's, where'd it go? And that's the only reference, but it's not, the index second try is not anywhere in this query plan. And if you want to get really into it and be geeky about it, you can go look at the XML plan and see that it shows up there. But anyway, so we've done all that. There's other examples here for I turn things on, turn things off, but it still comes out that if that second index is there, then you have issues. So with that, let's go back over to our conclusions. I'm hoping by now you're starting to get the idea that index column order can help or hurt you. And in one case, the Microsoft index suggestion was not necessarily the right one. I hope you now have seen an example where covered indexes can help update statements, and then unused indexes should either be disabled or deleted. I have in my utility zip file that I've included for download, I have scripts for missing indexes and unused indexes, and be wary of using them though, because they're only as good as when you last restarted the SQL Server. So I have lots of references. There's no particular order. If you're more interested, if you want to go out and look and do a lot of reading, there it is. I also want to put in a plug for a presentation I gave at past Summit, self-tuning fill factor technique for SQL Server. Video and slides can be downloaded at the thing there. If you download the PowerPoint presentation, you get hold of it. Fill factor scripts are found at GitHub, username ByrdTX. It's been running for not quite 2 years, almost 2 years, and overall performance of the database, wait times have dropped 25%. I really want to thank you for the organizers and attendees. And questions? Simon, are there any questions?
But before I get into a couple of questions that we have, Mike, what an amazing session. I see people really love it. Mohammed says, love this. And let me tell you a quick fact that we have had maximum number of people watching your session. We reached close to 450 people. So that is the maximum peak views we have had for any session. So really excited. And I loved your presentation. Very crisp and really enjoying. So
one comment, I don't know if you noticed my shirt here. It says Dirty Byrd. Well, I know dirty in some cultures means something else, but that was my call sign when I flew the Phantom F4. And
wow.
That is a Phantom F4 right there. And that's, getting paid to fly fighters is unbelievable. and being a rocket scientist before that, and now back to being a SQL Server geek, life is good. That's why I said earlier, I can't retire. I love it too much.
Wow, Mike, you are such a lively person. I mean, we would love to have you back in our different live shows that we do on C# Corner, and we would love to explore more of these SQL tips that you have. And before you go, I'll just ask you one question that comes from the comments, and that is what Paul Hunter would ask: does order of columns include matter?
I have not. That's a great question, and I get asked it a lot. I have never found a situation where the order made a difference. The fact that it's there, it allows then the predicate to take advantage of it. So
perfect. That's well answered. Thank you, Mike. Thank you for your time. Thank you for all you do for the community and speaking. We really appreciate it. Thank you so much, and we'll see you in a couple of months or when you're available. Thank you so
Okay.
much.
I enjoyed it too.
Bye.
And again, thank you. And thank you for putting on this conference. It's really a great conference.
Thank you so much, Mike.
Bye.
Bye bye. All right. So with that, we move to our next session. And next session is very interesting as we will talk about geospatial data in SQL Server. And to talk about this, we have a speaker joining us, Hasan, who is a Microsoft MVP and for data platform and a Microsoft certified solution developer. He works at Progressive Insurance as a business intelligence architect. He spent his days architecting cutting edge business solutions by using the latest web and database technologies. So without any further ado, let's go and have our next speaker, Hasan. Hi, Hasan. Welcome to the conference.
Hi, thank you for having me.
Oh, look at that. What are you wearing? Are you wearing a C-sharp kind of t-shirt?
That's right. Yeah, that's my second
Wow,
item.
wow, you came in branded.
That's right. That's right. Actually, I was going to even use my mask, but I was like, no, maybe that's too much.
All right, so Hasan, thank you so much for your time. We really appreciate it. I see your bio, right? You have been a community leader in your region. You organize many events, user groups, SQL Saturdays, code camps. So definitely, and you are an MVP. So thank you so much for all that you do for the community. And I'm really excited for your session that talks about geospatial data, and I'm really looking forward to it. So I won't take much of your time, and I'll add your screen
Thank
to
you
the
for
stream.
having me. Yeah, thank you for having me again. And
Next,
thank you for joining me.
yours.
Thank you for
Okay.
joining me today. I'm going to cover geospatial data today. I'm going to use the SQL Server as I guess, a platform. Some of the stuff actually I'm going to cover today here really applies to any other databases as long as they support the geospatial data type. So let me talk about myself. I'm Hasan Savran. I'm a Microsoft Data Platform MVP. I'm from Cleveland, Ohio, United States. And I have been doing like web development for almost 16 years now. And in last 7 years, I have been with Progressive Insurance and I'm in business intelligence area. So you can follow me on any of those platforms. I like to share a lot about the really, I write about C#, I write about Cosmos DB, SQL Server. So whatever I know, I like to share it there. So if you can follow me, I will appreciate it. And if you will have any kind of questions after this session, you can follow me from, or you can ask me the questions from any of those platforms. Also, I have this slide here. Usually I use this on my whole presentation. I just want to remind everybody that, those are the expectations from each event organizers and all the attendees. And it's okay to disagree on any topics or any opinions. And just don't forget to agree, I guess, to disagree. So I just want to remind that. And let's actually go into the presentation. So this is our agenda. I'm going to try to explain what geospatial data really is and how we save that data and how we retrieve the data in this presentation. And I'm going to actually try to explain almost like what you really need to know rather than just to give you the functions or what is available. I just want you to really understand what really geospatial data is and how it actually works before we throw you all those functions that you can use in SQL Server. So that's our going to be agenda. So let's start with try to explain what is really geospatial data is. Spatial data represents the information about the physical location and the shape of a geometric object. These objects can be really simple. It can be a point, which can drag you just like a maybe address or a location. Or it can be a complex object, like a polygon, which can represent a country, it can represent a road, lakes, pond, anything with the border, it can actually uh, represent that. Really, the geospatial data became available and most common data type with our mobile devices. Our cell phones constantly generates geospatial data. and they usually share that data with who knows what. So, for example, I have Samsung. I go actually my Google account and try to figure out, okay, like what are they actually know about the location. You can actually go to your Google account and actually download that information and see what they are tracking. So it was really surprising. Yeah, I was able to see all the latitudes and longitudes of my location, but Google really doesn't stop out there. It uses all other sensors of the phone and it tries to guess like how you are actually traveling. Since it knows the elevation, it knows the speed, it can guess maybe you are traveling with bicycle or you are on a bus, you are on a car. It tries to guess all kind of information. So if you haven't tried, it's kind of all kind of information out there you can see about yourself. So what else we can do with geospatial data? We need to kind of thanks to geospatial data whenever you try to actually go find your directions, for example. You just write the address, and thanks to geospatial data, we can actually serve and find that location for it. Or you can go maybe after your job, you're going to say that, oh, you know what, I'm going to go to an Italian restaurant today. So you can actually make a search for a distance, and it will find all the restaurants around you. You can look at the traffic. You can try to find what is the best way to actually go back home and try to get rid of the all that traffic time. Or you open the weather channel, you see all the snow is coming, rain is coming, whatever, we have the map. So all of those really, we are able to do those with the geospatial data. Also, in this picture here, you can see there's a map. And honestly, I have no idea what it's actually representing. But if you actually tell me what those colors mean, I can really tell you what is going on and who is doing good and who is doing bad very easily. So this makes your users' life very easy. They love maps because it kind of like gives it summary of the data, and it's very easily on the screen, and it's easy to read. It's much difficult to read this data if you're going to put, for example, on Excel. You have a bunch of numbers out there, and you really need to know what you are talking about so those numbers are going to make sense to you. But in here, it makes people's life easy. So people love it. I love it too. Maybe because of that, many products actually support geospatial data, including SSRS, Power BI, even Excel supported geospatial data. So now probably you're going to say, or maybe you even say that before, like, oh, somebody asked you to create a website. On the website, maybe you are doing like a store, maybe there are many stores, and they're asking you that, you know what, I want my users to actually go and find whichever is the closest store easily. So you have to figure out the distance. You have to figure out where the user is. Usually you can do that with maybe if you're using Bing Maps or Google Maps, they have some API, you can call them. But the problem is they are not free. So you can do that with the SQL Server for free. But where are you going to start? I was in that situation a couple of years ago, and there's a lot of articles on internet. But most of them is like really older articles. And SQL Server is developing. There are many options to do things. So I'm going to try to actually cover some of the, new information here with you. So first of all, if you're going to use this geospatial data in SQL Server, you have two data types. Those are geometry and geography. And those actually, geometry and geography applies to any other databases. So they're going to be the same, definition I'm going to cover right now. So let's start with geometry. Geometry is a CLR data type, which means that whenever you save the data, actually the data is getting saved as binary format. So if you're going to write a select all from a table and there's a geometry in it, it's really not going to make any sense to you because it's just going to be a binary format. Whenever you create a geometrical object, the easiest one we can give example is the point. You are going to need the X coordination and Y coordination. Whenever actually you are doing this geometry is almost like you are drawing on a piece of paper, right? It's 2D, and really each gap between each X and each Y are equal to each other. So that's really the geometry that you learn probably in high school. So the first thing you need to know about the geometry, the coordinations here you see, they do not represent latitudes and longitudes. Nothing is stopping you to actually use the latitude and longitude since they are numbers. You can't really use them. And your object will look like, for example, if you are trying to create the United States map, so you had all the dots of the United States to create the borders. You can do that with geometry. But if you do that, then actually you are going to actually accept Earth is a flat surface. You don't want to do that. Your shape that you're going to create with the geometry will look like United States, but whenever you try to find a distance between two or different areas, then you're going to have a problem. All of the calculations are not going to work. So your shape is going to look right, but all the calculations are not going to give you the right information. If you want to actually do and make more calculations and be able to find the distance between 2 points, or make a like a radius search, then you have to use the geography. Geography is just like geometry, and it's a CLR data type. Your data is in binary format. But now, whenever actually you create a point or a polygon, you're actually creating this on a curved surface, not a flat surface, just like Earth. And the coordination points that you are passing here, the X and Y, actually they are the real latitudes and longitudes of Earth. Many people say that geometry is 2D, geography is 3D. I don't agree on that, because just because you are creating an object on a curved surface, it really doesn't make it 3D. For example, if you are going to try to create a mountain and you have all the information about it, you cannot do that in SQL Server, because SQL Server does not take elevation. So your mountain is still going to look like a flat object. To understand that a little bit better, let's look at actually here. So let's say we have a house here, right? And we want to go from this house to that house out there. Now, you are going to get the locations of each objects, and you are going to run a function of SQL Server, and SQL Server is going to find what is the shortest distance between these two locations. Now, if you ask me first, if I didn't know all the stuff that I'm going to explain right now, I will expect something like this. So I think the SQL Server, probably that looks like the, I guess, easiest way to go. But I will expect SQL Server to calculate that slope out there, going up and going down. Actually, that's not the case. That's not going to happen. What is going to happen is SQL Server is going to ignore that hill, and it's going to actually find the direct line between those two objects. So does that mean my object is 3D? No, it doesn't. But there are times and there are ways to actually give those 2 points elevation and another number, which is measure. So whenever you are creating a geometry or geography, there are some ways to actually push X coordination, Y coordination, elevation, and another number. SQL Server call it measure. It can be any number. But in any calculations that you are going to run in SQL Server will ignore Z and M. So it's like they don't exist. Now, the next thing I'm going to cover here is SRID. SRIDs, they are defined by the European Petroleum Survey. And why do we need them? Well, unfortunately, our Earth is not this perfect kind of ball shape. So it can be sometimes tricky to find those real where the latitudes and longitudes are. The way that you are going to calculate where they are can be different if you are on a mountain or if you're in a cave. If we actually get rid of all the water out of the Earth, our Earth looks like this, most like a potato rather than, I guess, a ball. And there are many SIDs in SQL Server. You can find them in System Spatial Reference Systems table. I think there's like 500 or something. And they are really kind of almost like frames in different locations of the Earth. The main reason is right now, I'm in the United States, and there's a way to find, there's a unit United States uses. If you go to European, the unit might be changing. Or there are some countries, Some countries might say that, okay, I want the latitude first, longitude first. Maybe in other countries, it can be longitude first, latitude second. So because of all of these cases, we need different SNIDs. So what does this SNID looks like in SQL Server? Let's look at that. So I'm showing you the 4326. This is the default, which is actually used by Bing Maps, any of the GPS, and Google Maps, called WGS84. And you can see that it has 4 really required fields. The first one is the name of it. Second one is the datum. That datum actually tells you the shape of that frame. So if you are on like a mountain or a cave, the shape is changing a little bit. And this is a horizontal datum. The third one is prime meridian. That gives you where the 0 is. And also it's defining what the unit of that SNID is. So when you actually look at that, you kind of understand why SQL Server cannot calculate elevations or slopes, because you don't have a vertical datum here. We only have the horizontal datum. So there's no way that SQL Server actually can calculate those slopes because of this. Now, what objects can we create with geometry or geography? The first one is the most simple one, which is a point. And the point can be, representing maybe tree, pole, an address, a hydrant. It can be like anything. You can use line string mostly for roads, pipelines, rivers, railways. You can use that for them. Polygon probably is the most common one, I'm guessing. And anything with border can be a polygon. So it can be a country map, it can be a park, it can be a state, it can be zip code, it can be anything really with the border. Collection is available, but I don't really use it that much because the collection is actually, you can put maybe 2-3 points in it, one line string in it. For example, let's say you are representing a park, right? In a park, you have driveway, you have a pathway people can walk, you have some maybe pond in it. So you can put all of those in a collection. It sounds good. The problem is, that object is going to get really large. And when it gets large, it's going to be kind of, pain to kind of move in and move out from the SQL Server. So this is the first question probably you're going to ask yourself whenever you are creating a table. And this table is going to have some geospatial data in SQL Server. Which one I'm going to pick? Am I going to pick geometry or geography? So the best answer I can give you is, if you are, for example, creating a blueprint, and in here, this is a hospital emergency department blueprint. Now, do I really care where my rooms, latitudes, and longitudes are? I really don't, because the distance is really not the problem here, and that's not the problem I'm trying to fix. Probably I don't even have the instrument which is going to give me what is the latitude and longitude of each room here anyway. So in this case, geometry makes sense, and distance is not critical. Surface is flat, and really, if you are going to look at this map, what you're going to try to solve here is maybe you're going to change the colors of the rooms. If there's somebody in it, you can make it red. If it's available, you can make it green. Or you're going to give this to a visitor, and they're going to figure out where the cafeteria is, where the restroom is. So the distance is not critical. So we can use the geometry. Geography, though, now the distance is critical. So maybe we are calculating, how long it's going to take for us to go from point A to point B, or how much fuel we are going to need for the car or for the plane, or whatever we are creating. That means, distance is critical, and we want to actually find the right data. So geography, in this case, makes more sense. Now, let's look at some demo here. Let me actually show you how those looks like in actually SSMS. Now, as you can see, I am here using geometry, and parse is going to just create a line. I'm going to have 3 points here. So if I run that, This might be new for some of you, but since there is actually spatial data in my data set, you're going to have a new tab here named Spatial Results. You can click on it, and actually SSMS will show you the spatial data. You don't need any extension. You don't need to install anything. This is with the package, and as long as there is a geospatial data in your data set, this tab will be available. Also, what we have here is, this is another parse. And as I said before, there is a way to actually, I guess, push the elevation and a measure number. So what I'm doing here is, okay, this is the 1 and 1. This is the point, and this is going to be geometry. But I can push the z, which is not passing here, is null, and a number. It can be anything. So let's say if this is, for example, a tree, and this is the location of the tree, and I can make, I don't know, this tree is maybe 5 meters, right? Just pass it 5 there. And 0, I don't know, that can be the age of it. It's 30 years old. So if I push that and actually run that, it's still going to accept the data. It's still going to store the data if you're going to put in the database. But all you're going to be able to see and you're going to be available to you is the locations, which is the X and Y coordination, not Z and M. There are some other stuff you can do. You can create circular string, and as you can see, it creates that. You can create polygons. Let's do that. I'm creating a square here. Let's see what this one is. And yeah, actually, I'm creating 2 squares in each other here. This is a collection. As I said before, you can have many objects in one collection. And as you can see, I have 1 square here and 1 line here. This doesn't look maybe that exciting to you, but what you can do is you can actually get geospatial data free from many places. So that's what I did actually. I went to Census Bureau and get all the states of United States, and I put it in the database. Now, if I actually read that and select all of them, I have all the data here, and as you can see at the end, I have the geography. So if you actually go to spatial result, you are going to actually able to see the United States map. You can zoom in on it. If you like, you can change the labels. You can do anything like that. And I didn't need to download anything. It's just SSMS. All right, so let's go back and continue. The next topic we have is the common geospatial formats. So there are many formats out there, and those are the common ones that I'm going to cover today. You might need to know them because you need to import and export data, and you may need to your data might come in one of those formats. The first one is the WKT, which is the well-known text format, and that's probably the most readable format. As you can see, it's pretty easy to understand what's going on, but whenever you have a lot of points, it kind of gets unreadable. You're not going to be able to figure out what is happening if it's a polygon. It's a point and multi-point, yeah, it makes sense, but after a while, it gets kind of confusing. But good part about it is your data might be coming in this format, and you can just take this and import in database in SQL Server or really any databases if they support geospatial data. Next one is GML. As you might guess, it's an XML format. And I think Google Maps still using, I think they call it KML rather than GML. It's very similar to this. And the third one, well, everybody's using JSON now, so we have GeoJSON. And the good part about the GeoJSON is as you can see here, okay, this is a geometry object, and I have my coordinates of point, but at the end, I can actually add custom properties here. That means that, for example, when you go to Google Maps and you hover on any kind of objects on Google Maps, some information can come up. They can tell you the address, they can tell you what time they open, or anything. So you can really put them in here and push it on the front end. And whenever a user clicks on it or hover on it, you can just display this information very easily. And SQL Server 2017 and later can generate GeoJSON objects in database. And if you want to know about that more, you can check my blog. I actually have it for step by step. I will not be able to do that today because I don't have that much time, but you can check my blog for that if you're curious about it. Next one is shapefile. So I kind of include the shapefile here because usually I get my data from Census Bureau and the files are in shapefile format. And you might need to actually take that and kind of convert it to, to use in SQL Server. And there's one tool out there, free tool that you can use, or there are many third-party tools you can actually use. And again, check my blog if you are really interested how to actually import the data from Census Bureau and kind of shape files to SQL Server. Now, next, we are going to cover the spatial functions, some of them, not all of them. So first of all, SD intersection is creating an object from two geospatial data. And it just finds you the intersection between two. The next one is ST union, which actually takes two geospatial data and makes one. The third one is ST difference, which actually gives you the difference between two objects. ST geom from text, which actually I just demoed that a little bit ago. It just takes a WKT format and converts it to binary format. Parse is working the same way. The only difference between parse and ST geom from text, I believe ST geom from text, you can push Z and M, which is the elevation and measure if you want to. To string, you can actually call the strings for any geospatial data, geometry, or geography, and it will return you the WKT format. If you want to see the Z and M, you can use the S text ZM, and it will give you all the Z and M values. As GML will convert or return the data as GML. And we have ST length, which will give you the length of the object. We have the ST area, which will give you the area of the object, and ST intersects, which I use it a lot. It just returns true or false. You are giving two objects, and it's really answering you if they're intersecting or not. And ST distance gives you the shortest distance between two objects. Now, let's try to actually see how these things work. So in here, what I'm doing here is I'm just creating two geometrical objects, a square and triangle. And I'm just using union also. You can see both of them in the same area. So that is our source. And we are going to actually start to use some of those functions. The first one I'm doing here is the ST intersection. And ST intersection, as you can see, is giving us what is getting, intersected. So let's see here. We are getting really, when you run that, you are getting this area here as a result. So that's the area that intersected. Next one is ST union. And when I run that, actually these two objects becomes one object here. So let's talk about this one, because this one's pretty useful, especially if you are, working like one of those big corporates and you have actually zones. You have East zone, West zone, I don't know, middle zone, whatever you want to call it, central zone. So you have many states or places out there. So you can really join the states and you can make it like 3 zones, and you can really do custom objects by using this. So it's pretty useful. ST difference is going to give you the difference between two objects. In this case, this area is a difference here. That's what I'm getting. And well, this one, a lot going on, but don't be scared. So what we have is a square. And I'm just saying I'm going to have another object, which I run the square ST centroid. ST centroid finds the center of the square. Then I'm putting an ST buffer for 10 meters here, and it just creates a radius on that center. That's what's really happening here. Also, we have some other functions that I talk about. As you can see, as text ZN, when you see right that, you will see that this is geometry or geography, doesn't matter. This is the X coordination, Y coordination. 1 is the elevation, and 5 is the measure, which can be any numerical number. So you can actually see it like that by using the S-text ZN. When you write the as GML, you get your result in GML format. And you can use the st length. That gives you the length of the object of square. And this one, as I said before, I use it a lot. And as you can see, I'm saying, does square intersect in y triangle? And that gives you 1, which means yes, it does. And the last one we have is the st area, which gives you the area here. This is where SRID becomes very important, because those numbers, you kind of need to know what SRID you're using, what unit you are using. So whenever you actually download this data from anywhere, you want to be sure that you get the right SRID from them, so you can actually, I guess, put that SRID with the objects. All right. What about finding distance between 2 points? How easy is it? So to do that, I'm going to actually go to Google Maps, and I'm at Ohio. So Ohio's capital is Columbus. So I was going to find the latitude or longitude of Columbus. So that's pretty easy to find. It's public information. There are many places you can use. Next, where's our destination? Well, so I have the Hawaii's latitude and longitude here. Now, if you actually look at the larger picture, this is what's happening. So I want to go from here to there, and I have their locations information. And I want to actually find what is the distance. I'm using only SQL Server. I don't want to use Google Maps. I don't want to use Bing Maps. I have all my data already, and I want SQL Server to find a distance. To do that, first, we have to declare to Ohio, right? And I'm passing the latitude and longitude, and I'm using just the default SNID here for each objects. Then I declared Hawaii. Then I use the ST distance. I'm saying, what is the distance between Ohio and Hawaii? I'm just dividing to this number because in the United States everything's in miles. So rather than meters, I want to see in miles. So that's the whole reason I have that. Now, when I run that and click F5, I see this number. This number doesn't make sense. What happened here? It says it's not even 1 mile. That is wrong. But when I look at the details, it looks like I picked the wrong data type. As I said before, when you make the geometry, it's almost like you really, on piece of paper, you just put kind of like 2 points, and well, the distance between those 2 points is not going to be that much. So to fix that problem, we kind of have to pick the right data type. So rather than geometry, all I'm going to do is I'm going to change it to geography. Everything else is same the latitude, longitude, and I'm using the same exact function. Nothing is different. And when I run this one, actually, then you are going to be able to see the right number. It's 4,467 miles. So it is important, geometry or geography. And the problem is, if you are not sure, and if you put the wrong one, like the geometry, and if the data is already in SQL Server, it's not going to be that easy to fix that problem. So just pay attention and try to get your requirements right. So whenever you are creating the data, you can actually pick the right one. Next one. In the United States, we have this website named Zillow. It has a user-friendly page because it's using the maps. So they use it to actually find houses for sale. Right? So you go to the website, you open it, and usually when you want to buy a house, you know where you want to actually buy that. And you maybe a school district is important for you. You want to maybe like close to a sea, whatever. With this application, what you can do here is you can actually create your own polygon if you like, or you can pick one of the polygons out there already defined. It can be a school district polygon, it can be a state, it can be city, zip code, whatever. And when you pick that, you only see what's available in that polygon. So it makes it much easier to actually make the search. Can we do that in SQL Server? Well, we can try it, and it's really not that difficult. So here's the demo I'm going to give you right now. So what we are trying to do here is, let's say we are creating an application. And in our application, we are going to try to find the public parks, right? So to do that, actually, I go, most of the cities has this, public information that you can go and find all kind of spatial data. So I went to Columbus website, and I find all the parks. There's like names, there's the latitude and longitude of them, right? So I have my data in SQL Server. Now, to make a search on that table, what I'm going to need is probably the location of this user, which probably is going to be shared by, I'm guessing, by the cell phone. And also, we are going to need another number, which user needs to tell us, like the radius, like where are we searching this from. So those two numbers are going to come from the web application, and we have the data already in SQL Server, and we are going to be able to find the data by searching the area by a polygon. So let's actually do that here. Let's see. Now, to do that, let's see here. First, we need the data. So I'm creating a data table here named distance demo. And the latitude and longitude actually is coming from that website that I found. But they are not giving me a binary format. They are just giving me a number. So I'm just using a float because of that. Also, I have a geography here, which I'm going to be able to convert this later after I'm done here. And I want to put the name of the park here. So as you can see, I'm just pushing all those numbers, and which really they are not geometric yet because they are just float here, right? So we do that first. Then what I'm doing here is, then I say, since I have this latitude and longitude, I can update the geog, which is the geography here. And I'm taking the latitude and longitude, and I'm using the default SRID, which is the 4326. So let's do that first, and let's actually put the data in our table. Okay, we have 29 parks in our database right now. If you want to see them, you can just write the select. And since there's a geospatial data in it, you're going to see the spatial result here, right? But the problem is right now everything is dots, and it's not going to be easy to find it. But that big dot actually has all the parks in it. So you can really zoom in, but it's not going to be easy to, as you can see, they are very close to each other, but that's where our data is. Now, it's time to actually start the development, right? So as I said before, what do I need? We need the location of our user first. And that's going to come from the application. As application is going to give us the latitude and longitude. And I'm still using the SRID. This is important. You need to use the same SRID what you have in the database. So, and also, I need to create this radius. I need to create this polygon so I can actually make the search. So that has to be in meters. And all I'm doing here is, this is the miles, because probably that person is going to give me a mile. So I can say that, okay, let's start with the 5 miles. And that's going to be, let's see how many meters is that. 8,046 meters. So we have those two numbers. What do we do now? Actually, let's look at the user location. So user location, this is the location, but as you can see, I'm putting the SD buffer here, which is getting the meters, and this is going to create a radius. And let's look at that, what it's going to look like. As you can see, this is the area I'm making a search. If I change this one here and make it 15, this circle is going to get larger. So it's going to be a 15-mile radius. And I'm going to find more data, as you can see. So let's start with 5 first. I'm going to use this 2 parameters. And I'm going to go and look at my data table that I just created, distance table. And I'm going to find all the objects this table has, which is intersecting with what I'm actually giving. So I'm giving user location is intersecting with anything in my table. So if I run this, it's going to find all the parks in close to 5 miles. That's what I'm searching. So if I go here, you're going to actually see there is one there, one here, one here, one here, and one here. So if you want to actually change this, if user goes and changes the radius on the UI, and let's say he or she make it 15, then I should actually find more than 6, hopefully. There we go. Right. Looks like I have found 18. So this kind of looks the same way that the example I just showed you, that whenever you try to buy a house, you create your own polygon. So this way you can do the same thing in SQL Server, and you can actually find the data pretty easily. All right, so looks like I have a little bit more time, so I can actually show you another demo, which is great because I like this demo. The next demo I'm going to show you is a little bit more complex. So let's say it calls hurricanes. You can get all the hurricane information. It's free. You just guess the location. So, Katrina was a pretty big one in 2005. So what I did is I go and get the Katrina's geospatial data. So it sounds very complex, but really, all I'm doing is I'm getting latitude and longitude of the eye of the hurricane. That's all I'm getting. So if you look at this, for example, this is the Katrina, and I'm getting all kind of information for each time they kind of, measure it. And I'm getting its latitude, I'm getting its longitude. That was the speed of the wind. And I get all kind of information that I can use. So what I want to do here is, okay, so I have a bunch of them. If you look at the spatial results right now, it looks like that thing has a lot of dots go this way and go that way. So those are actually where the eye was moving. So what I have in here is I have the wind speed. So what I can do here is I can actually try to make circles rather than dots. I can try to make circles, and the circle radius will depend on the wind. So I came up with some kind of very simple calculation here. And let's actually do that first. And also I am joining this to my zips table, which has all the zip codes. So I can actually make a join between the hurricane eye and the zip codes. So if the hurricane is on, usually like I think this area is ocean, and there's no data here, there's no zip codes, nobody's living out there, so I'm going to ignore that area by just joining to zip table. So let's actually run this one as the same data, but now I have less data because, well, I just ignore the ocean area. And this was when actually hit to the land first time, and the wind was really high. And as you can see, my circle is larger. So if I'm going to make a search under this circle, if I have any customers, this is a larger circle than the rest of them because probably the most damage happened here. So that's why I'm trying to make a bigger search. Now, next, what I'm doing here is, yes. So I have the circles, but as you can see under that, there are some gaps here. So I don't want to kind of, ignore those areas, right? I want to actually create a line going from here and here first. So to do that, I'm going to actually, let's run this one first. I'm going to use the line string. As you can tell, line string creates a new line. And I'm just really using some of the new functions of SQL Server, string add and concat. And I'm just taking all those latitudes and longitude and latitudes and put them together to create a line. So I can do that really dynamically here. And if I can show you this here, you're going to see actually a line that I just create myself on SQL Server. This is the line of Katrina. Well, I cannot really make a search under that line, right? Because it doesn't cover that much. So I can just put a buffer on there. And if I actually do this, I will create, this is going to create a 50-mile buffer. And if I do that, then my line is going to be mostly a searchable line. So I can actually try to see what's on it. Let's go over here. So I changed line. My line is much thicker, so I can actually try to find if I have any kind of customers under there. To do that, as I said before, actually I have the zip codes and I know the zip code shape. So what I'm going to actually use is my table named zips. And I'm going to say that, okay, do I have any zip codes under this line? To do that, I'm just going to run this and execute it. Looks like I have 152 zip codes. This is how many people are living under them. And if you look at the spatial results, you're going to actually able to see those zip code map. So I can zoom in here. As you can see, those are the zip codes that Katrina actually hit. And from here, what you really need to do is, okay, I find the data. Now I need to join this table to my customers table, maybe so join by the zip code, find all my customers and try to maybe follow up with them or try to analyze this data, how much damage happened and how much, I guess, I need to kind of pay or customers need to pay me depending on what industry you are in. So I like this demo. This demo is really a kind of eye-opener for geospatial data. Anyway, well, it's 43 minutes, and I think I did great. Thank you for joining me today. I hope everybody learned something new. And please follow me in LinkedIn or Savran at Twitter and check out my blogs. I have a lot of information out there for geospatial data too. Thank you.
Wow, that was a really interesting session. We don't see many people talking about this geospatial, right? And I just love those graphs and all that you did. We have a couple of questions that maybe you would like to go ahead and answer it, and I'll just put it on the screen. The first one is from Bhaskar. He says, how to migrate post geospatial data to MS SQL spatial data.
So I think the PostGIS, if you can actually, I'm not sure, I've never used the PostGIS, but as I said before, WKT, which is a well-known text, will be the, I guess, most easiest way. You can convert from PostGIS to WKT, then you can maybe need to write SSIS package, get that file and create geometry or geography object. That will be the easiest. Or if you can check my blog, there's another kind of free application. You can actually try to use that too if they're in shape files.
Okay, perfectly makes sense. We have one questions coming from your choice. I just wonder if your choice is the name, but never mind. If you have spatial data for SQL Server, can you use the spatial data both for geometry and geography in another application, for instance, ESRI or ArcGIS?
I think you can, as long as you can use it as source, and if they accept a SQL Server, I don't see really why not. That's mostly like third-party application S3. I think I'm not sure what they are, supporting, but as long as they accept the source as SQL Server, I don't see why not.
Perfect. So we have one question coming through our forums. So I'll just put it on the screen. The final one that we have is, can spatial data in Oracle be imported into SQL Server? I think this is just like first one.
Yeah, so as I said before, the geometry and geography I show you kind of applies to any database, which actually applies to geospatial data. The only thing you have to do is just, you might need to convert to one of those formats I show you. Probably the easiest one is the WKT because it's the most common one. Mm-hmm. As long as you can find a way to export that to WKT, then from there you can just import to SQL Server. You can read from WKT and it will be binary format.
Perfect. So I think that's all we have. And Bhaskar says thank you. Thank you. So thank you so much, Hasan. Thank you so much for your time. It was a lovely session, and we would love to have you back when you're available, right? And thanks for your time on weekend, and thanks for all that you do for the community. We really appreciate it. And thank you so much. Have a nice weekend.
You too. Thank you very much.
Bye-bye. Take care.
Yep. Bye-bye.
All right, with that, we move to our next session. That is by Frank Gill, who's going to talk about performance improvement in SQL Server 2019. So let's go and have Frank Gill. Hi, Frank. Welcome to the SQL Server Virtual Conference.
All right. Thank you, sir. Can you hear me okay?
Yeah, your voice is loud and clear, and your video is perfect.
Okay, great.
And how are you doing actually
awesome.
this weekend? Thank you for joining on the weekend.
Oh, well, thank you for the opportunity. Yeah, I'm doing okay. It is cold and snowy here in Chicago, but it is winter, so I can't complain too much.
Well, winter has come.
Yes. And how are you today?
Yeah, I'm doing good. I think we are now just going towards the end of the day. This is the third final session that we have,
All
and we're
right.
really excited. And it's been a really good conference. We reached more than 20,000 people,
Oh,
and
that's
really
awesome.
looking forward to your session.
Yeah, I'm looking forward to it myself. That's a
Okay.
great number.
Mhm. So you can go ahead and start to share your screen, and then I'll go
Okay.
into the live stream.
All right. Have you got my title page?
I'm just waiting. I don't see your screen now.
Let me make sure. Let's see. Ah, there we go. Share.
By the time you do it, I can answer a question. Someone asked, how often do you guys have these sessions? So ALO1, we do live shows every day. You can say we do live shows 8 days in a week, and we do these virtual conferences mm, every other week. So you just visit csharp.live and you will find our live shows. So I have your screen now. Let me go ahead and see. I have your slides.
Okay,
Perfect.
great.
So next 45 minutes is all yours, Frank.
Okay. Well, thank you again, Simon, for the opportunity to present. I am going to talk about performance improvements in SQL Server 2019. And just a little bit about me. I've been working in IT for 21 years. 13 of it, the last 13 of it, have been working with SQL Server. I'm currently a senior data engineer at a consulting company called Concurrency. In addition to SQL Server, I'm learning more about Azure every day, and I'm really interested in SQL Server internals. And I'm going to get somewhat deep into internals in this presentation. When I'm not working with SQL Server and other tools in the Microsoft Data Platform, I love to read. I volunteer at the Art Institute of Chicago here in Chicago, and I hang out with my cat and my wife. I should probably put her on the slide. But my contact information is here. You can reach out to me on Twitter, via email, and the slides and scripts for this presentation will be available at my blog. And then, Simon, I want to touch base with you after this and just figure out if there's a place I can put them for the conference itself. But just the topics we're going to cover, I'm going to talk about the transaction log and how the transaction log is architected in SQL Server. And then I'm going to talk about the crash recovery process, both in versions prior to 2019, and then how that crash recovery process has changed with a new feature in 2019. And then I'm going to talk about putting TempDB metadata in memory, which is another feature that is available in 2019 and can help improve performance. And then finally, I'm going to talk about persistent memory. And that is a hardware-specific feature that SQL Server 2019 has been built to take advantage of. And I'll talk about how you can use that. So quickly, I'm going to talk about transactions. So any relational database management system uses transactions to encapsulate units of work in the database. And in SQL Server, every transaction begins, and then a transaction can commit or roll back. And in SQL Server, the default behavior is auto commit. And what that means is that if I go into Management Studio and I say delete from table and I don't give it a where predicate, it is going to delete all of the rows and it's going to wrap that transaction in a begin transaction. And then when those deletes complete, it will commit that transaction. So SQL Server, when you create a database, you get at least two files. You get a data file, and this is where your data is stored, and all of the information about your database schema is stored in that data file. But then all of the transactions that are run, and effectively anything that changes in the database, data or schema, is written into the transaction log. And SQL Server does everything it can in memory because it's much quicker to access memory for both reads and writes than it is to go to disk. So those changes are written to the log buffer in memory, and then that log buffer is flushed to disk, and it's flushed to disk at 2 points. One, when you commit a transaction, it will flush that buffer to disk, or when that log buffer fills up. And so the data pages that are associated with your changes can remain in the buffer because, like I said, it's much easier and quicker for SQL Server to go and get those pages out of memory than it is to write them to disk and then pull them back into memory. So quickly, how the tran log works. And then just in terms of transaction log architecture, when you create a database and that transaction log file gets created, it is divided into logical units that are called virtual log files, or VLFs. And a VLF can have one of two statuses. It can be active or it can be free. And if a VLF contains log records that SQL Server needs for something, that VLF will be active. And you're always going to have at least one active VLF because SQL Server needs somewhere to write those log records to. And if you're in simple recovery mode, a VLF can be freed. If the VLF doesn't contain any log records that SQL Server needs, a checkpoint operation will free VLFs. And you can manually run a checkpoint. In Management Studio, you can just type checkpoint and hit execute, and it will run a checkpoint. Under the covers, SQL Server runs a checkpoint approximately every 30 seconds. Now, if you're in full recovery, you need to run a log backup to free a VLF or free VLFs. And this is why if you are running databases in full recovery that are transactionally active, you want to be running log backups on some schedule to free up VLFs. And reasons that SQL Server may need a log record are for rollback, and I'll explain more about rollback when we get into crash recovery, but then things like high availability. So if you are running availability groups, for example, log blocks are being transferred from your primary replica to your secondary replicas. So the VLFs, the log records in the VLFs may be required for high availability as well. So to give you a visual of what this looks like, this is a very simple example. I've got a transaction log file with 4 VLFs, and this is, for example, a newly created database. So VLF1 is active because I need somewhere to write those transaction log records. VLFs 2 through 4 are free. So at this point, I start transaction 1, and transaction 1 completes. And while transaction 1 has been running, those log records have spanned into VLF2. Tran 2 starts and completes, and transaction 2 has spanned into VLF3. So I now have 3 active VLFs. Now transaction 3 starts, but transaction 3 has not committed. You can see because of the arrow that indicates that that transaction continues to run. So at this point, I have 4 active VLFs and 1 open transaction. So at this point, if I run a log backup or a checkpoint, depending on the recovery model of my database, I free up VLFs 1 and 2. VLFs 3 and 4 are still active because Tran 3 is currently open, and SQL Server may need to roll that transaction back so it maintains those VLFs as active. So at this point, if I get here and I don't run a log backup or checkpoint, what will happen, there are 2 different things that can happen. The first is there's a setting when you create a database on the log file, actually on all of the files in the database, called auto grow. And what that says is when I reach the end of a file, SQL Server will ask Windows for space and grow that file by the amount specified. So if I don't have auto grow on and I hit the end of my file, what happens is a computer malfunction. Effectively, you'll start to get error messages in your error log that say, I can't write to this database because there is no space in the transaction log file. So that's bad. You don't want that to happen. I believe the error message, the error number is 9003, and it will specify the database, and it will tell you what file it is that can't be written to. Now, if you do have autogrow on, what will happen is tran3 will hit the end of this file, and it will add a VLF or VLFs, depending on some factors. If you're running a version of SQL Server prior to 2014, there's a fixed number based on the size of your autogrow parameter. It's either 4, 8, or 16. And then after 2014, there's a more complicated formula that runs, and it takes into consideration the existing size of your log file, the size of your autogrow, and then it will add either 1 or 4, 8, or 16. And the reason that they've tried to reduce the number of VLFs that are added is that the more VLFs you have, the harder SQL Server has to work to process the transaction log. And that includes things like transaction log backups. It includes rollback, which I'll talk about in a second. And it also involves any sort of high availability. So if you're running an availability group and you have more VLFs, SQL Server has to do more work to process that transaction log. So that is TranLog architecture. Simon, do I have any questions at this point?
Frank, we are good to go now.
Okay. All right. So I'm going to talk about crash recovery. And so I said, any relational database system is going to use transactions. And two of the things it uses transactions to do, and then transaction log in SQL Server's case, are to maintain consistency and durability. And what that means is that if I make a change to a database, if I run a delete, and let's say the table I'm deleting from has foreign key constraints, the foreign key constraints at the end of that delete have to be processed. And so I have to go from one consistent state in the database to the next. Durability means that as soon as that transaction commits, I've got to be able to have that change durable in the database. It's got to maintain no matter what happens after that point. And so to maintain consistency and durability, when the SQL Server process restarts, it scans through the transaction log for each database, and it checks for two things. And to do this, it runs through 3 phases. And the first phase is analysis, and that's where it checks for transactions that were written to the log. So transaction committed, the log blocks associated with that transaction were flushed to the log file on disk, but the data pages associated with that change were still in the buffer at the time of the crash. The other thing that it checks for is transactions that were open at the time of the crash. For example, I've got a delete statement that's going to delete 1 million rows out of my table. I get halfway through, so I delete 500,000 of those rows, and my system crashes. When SQL Server comes up, it will see that transaction that is halfway complete, and because of another feature of relational databases called atomicity, a transaction is all or nothing. So it can't have that transaction be halfway done, and it will roll those deletes back. So once the analysis is done, it will redo any transactions that have been written to the log file but not to the data file, and it will write those pages back out to the data file, and then it will undo those uncommitted transactions. And to show you what this looks like, once again, I've got my 4 VLFs, and it runs that analysis from the oldest uncommitted from the oldest checkpoint going forward. And this will allow it to find both the transactions that committed but did not flush the disk. It does the redo from that oldest uncommitted transaction going forward, and then the undo from that oldest checkpoint going backwards. And this can cause some problems if code is not written to process transactions in an optimal way. And a phone call that I've gotten a number of times in my career is, it's 4 o'clock on a Thursday, an application area calls and says, hey, we kicked off a delete against this table at 8 this morning. Can you kill it? Because it's still running and we want to kill it because it's causing blocking. Now you can kill it, but what you need to tell them is that because of this undo process, when you kill that transaction, it is going to roll that transaction back. And that rollback can take as long, if not longer, than the process going forward, because it has to process each of those deletes individually. And this is a reason, and I've got presentations about batching transactions. Batching transactions is a good idea. And the same thing is true if that delete is running for 8 hours and the system crashes or an availability group replica fails over, that same undo activity has to take place. So that is how it works prior to 2019. With 2019, there is a new concept called accelerated database recovery. And ADR introduces a number of new concepts. The first one of these is the persisted version store. And what this is a version store that is at the database level. So you turn this feature on per database. And when you turn it on, this version store gets created in the database. And as you are modifying data in the database, the previous record, so I go to update a row. I go to change column in that row. Prior to that change happening, the previous version of that row gets written into the persistent version store. And that way, if I have a long-running transaction in the prior world, when that transaction was rolling back, anybody trying to access the row or potentially the table that was being modified would be blocked for the duration of that rollback. Now, when that transaction rolls back, anybody trying to hit that table and pull that row back will get the version out of the persisted version store, and my rollback can continue, but other transactions can continue to process. So that is where changes to the data happen. There are a handful of non-versioned activities that go on, things like system metadata changes, or locks for data definition language, or cache invalidation that can't be versioned. Those are written into an in-memory log stream called the slog. And that activity is much less in volume than transactional activity in an OLTP system. So the amount of data that's written there is minimal, and it's also resident in memory. So that will speed things up. And then finally, there's a cleaner process involved in this. So I'm writing these versions out to the persisted version store. At some point after changes have been made and things have been flushed both to log and to disk or to data, I don't need those versions anymore. So there's a cleaner process that comes through and cleans those up. So just to show you what this looks like, once again, I've got my 4 VLFs. I run my analysis from the oldest checkpoint going forward, but the difference is that I have just to do my redo from that streaming log. So this is that in-memory area that is tracking non-version changes. So because volume is lower, this is in memory, that runs very quickly. I then redo from my transaction log, but I'm only doing the redo from that oldest checkpoint going forward. And because that checkpoint runs approximately every 30 seconds, that volume of data is very low. And then finally, I have an undo from that streaming log. So once again, low volume of changes to the slog in memory, runs very quickly, and I am done. So the benefits of accelerated database recovery are faster crash recovery, faster AG failover, and faster rollback. And then an upshot here is that because SQL Server can truncate the log more quickly and more often, your transaction logs will be smaller. So in the case of that delete, let's say I'm running that delete, I am going to generate log records for all of those deletes. And while that transaction is open, the VLFs that are being written to and potentially created because of that delete can't be freed, because ADR allows those VLFs to be freed more frequently because those log records are no longer needed for rollback. It allows that truncation to happen more quickly and more often. So, and then the other benefit here is that this is available in standard edition, which is a big deal because this ADR changes the way that the transaction log processes. It changes the way that you can write applications and maintain your log data, your log file. And because it's available in standard edition, it's available to pretty much anybody running SQL Server. And this was announced in November of 2018, the year before 2019 released. And when I heard about it, I was asking people I knew at Microsoft, is this going to be enterprise only? And they said, we don't know, we think so, but we're not sure. And so when it was announced with the release of SQL Server 2019, they announced it was in standard edition, and I was sitting in a room in Seattle, and I looked quite like this. It was very, very happy because, as I said, it is kind of a game changer. So, any questions about ADR at this point, Simon?
No. Good.
Okay.
We may take it towards the end.
Then I am going to jump to a demo. Can you see Azure Data Studio?
Yes, but maybe you'd like to zoom in a little bit or increase the font.
All right, let's see. How's that?
Yeah, this is better.
Okay, great. Okay, so I'm going to run a demonstration of Azure Accelerated Database Recovery. And as I said, these scripts will be available to you. And what I've got here is a create database statement. And I've already done this, so you don't have to sit through this to create and populate. But I'm creating a database called White Sox. It has a data file and a log file. And then I am adding a file group specific for my persisted version store. And this is something that you can do, and it is recommended. And then I am creating a table that has two columns, an int column and a car 7000 column. And then I've inserted 100,000 rows into it. Those rows all have the same value except for that primary key. And then I have I've verified that accelerated database recovery is off. And as I said, this is a database level setting. So in the sysdatabases table, there is a column, and my results are saved here, and you can say that that is set to 0. So that is off. So what I'm going to do now is confirm that that's off, and then open a transaction. So I've explicitly coded a begin transaction, and I'm going to delete all of the rows from that table and leave that transaction open. So I'll kick this off. Should run for about 30 seconds. And then once that's done, I'm going to check to see how much space is used in my log. And then I'm going to run a checkpoint explicitly and see if that frees any space. So give this another second. All right, so it deleted the 100,000 rows in approximately 31 seconds. So if I run this, it should come back pretty quickly. And you can see that 78.66% was used, and the same amount with a little bit extra was used post checkpoint. So that checkpoint did not free any space in my logs. Now I want to roll back those deletes. And as I said, it's going to effectively generate an insert statement for every row that I deleted. So let this run, should run in about the same amount of time. Time always seems to go longer when you're doing a demo. Okay, so 32 seconds took to roll back. So I'm now going to enable accelerated database recovery for my database. This is a database level change. It doesn't require a restart of SQL Server. So I'll run that, runs pretty much immediately. Run the same deletes. So I'm beginning my transaction, deleting all the rows. And this should run a little bit quicker, fingers crossed. And once that completes, I'll do the same check of log space usage. All right, so 11 seconds this time versus 31. I run my log space usage. You can see that prior to my checkpoint, I used 25% of my log. So I used more than a third less, or 2/3 less than the usage without ADR. And then my checkpoint freed up about 18%. So effectively, I'm using, after that checkpoint, about 1/10 of the log space that I used on the front end. And this is because of the persisted version store and the fact that SQL Server can truncate that log more quickly or reuse those VLFs more quickly. And then the really cool thing about this is I'm going to roll this back. And where before it took about 31 seconds going forward, 33 seconds to roll back, my rollback is now done in 6 milliseconds because the rollback is still going on behind the scenes, but from a SQL Server's perspective, it will be able to access those rows from the persisted version store. So that's why I say this is a real game changer, both in terms of the way that it handles transactions, as you see here through the rollback, also for availability group failovers. It will speed that process up dramatically. So that is accelerated database recovery with a demo. Flip back over to my slides. And Simon, if you get any questions coming through, just let me know when I pause.
Sure, Frank, I'll let you know.
All right. So the next thing I want to talk about is in-memory temp DB metadata tables. So if you've worked with SQL Server and you've worked with temp DB, you'll know that temp DB is one of the system databases in SQL Server. And it's used for a number of different things. You can create temporary objects there. You can use it for sort space. And everybody uses it. And it can cause contention. And one man's opinion, this is from a presentation that I saw probably about 6-7 years ago. Brent Ozar talked about temp DB as SQL Server's public toilet. You don't know what people are doing, and you want to get out of there as quickly as possible. And there's a link in the slides to more description about that presentation. So there's an old contention problem in temp DB, and that is that, as I said, when you create a database, you get a data file and a log file at minimum. And that data file contains metadata pages that track page allocation in the database. So as you're creating an object, there are pages that tell SQL Server what pages are available. And in a regular user database, these allocation pages aren't a bottleneck because when you create a table in a user database, you aren't generally doing a lot to it. You create a schema, and that schema is fairly static. You may add a column, you may change a data type, but that table is going to remain in your database. In temp DB, because you're creating and deleting temporary objects on a regular basis, those pages can act as a bottleneck. And so the old contention solution is to add data files to temp DB. And the general rule of thumb is to start with 8. And then if you still have problems, look at adjusting that number up or down. And what that does is increases the number of those metadata pages. And it allows SQL Server to effectively parallelize that activity. So that's great, but that pushes that contention down the road a little bit. And that new contention is that as you are creating and deleting those objects, there are system tables that store metadata about those objects. And once again, this isn't usually a problem because those objects are static in a user database, but because the tempdb tables are constantly created and deleted, you can get a bottleneck. And the problem here is page latch waits. And once I kick off my demo, I'll explain a little bit more about what page latch waits are. But the solution to this problem is to put those tempdb system tables into memory. And what this does is it eliminates latch contention. And I'll explain how it does that using in-memory while I'm running the demo, which I will jump to now. All right. So for this demo, I have a second database called Chicago White Sox, and all Chicago White Sox contains is a stored procedure called Let's Go Sox. And what that stored procedure does is it creates a temp table. So it's going to create that temp table, and I'm going to run this a bunch of times. I want to validate that the in-memory optimization for tempdb is disabled. And to do that, I am going to run run this command file, and this is going to disable the optimization, and this is an instance level setting. So when you change this, you have to stop and start SQL Server. You've got to restart the service, and this command file will do that. I'm running this in a container, so it's made the change. It's going to stop my container, and then it will start it. And you can do this on a regular instance of SQL Server. You just need to modify this script to stop and start your SQL Server service. So this will take a second, and I was having some issues with this demo this morning, so I'm going to give this a shot, and if it doesn't work the way I expect it to, I have all of the results saved. All right, so SQL Server has stopped and started, and I'm going to attempt to run this. This is a utility from Microsoft called OStress, and this is available for free download. And what this does is it connects to my instance, and it's going to execute the store procedure Let's Go Sox, which is going to create that temp table repeatedly. And it's going to stand up 20 connections that will run that procedure 2,000 times. So that is that 400,000 for 40,000. It's going to execute that procedure 40,000 times. And fingers crossed, this works the way I want it to. And it does. So while that is running, I'm going to execute this query. And what this query is going to show me is all of the occurrences of page latch waits. So if we scroll down in here, you can see that I have approximately 20 page latch waits. And this is page latch shared and page latch exclusive. And these are all on database ID 2, which is the tempdb database, in the first file, which is my one data file in tempdb, because I haven't optimized this, and they're all hitting page 116. So flip back over to my slides, and this is how latching works. So I've got my data file with my data pages in it, and this is where the data in tempdb resides. And when I go to update one of those pages, it reads it into the buffer cache. And while it is in the buffer cache, it takes an exclusive latch on that page. So if you're familiar with locking is to protect the data pages themselves. Latching is to protect that page in memory. So it prevents anything else from hitting that page in memory while that exclusive latch is held. So I make my update, that exclusive latch gets released, and the update completes. Now, because those metadata pages that I talked about are accessed for each creation or deletion of a temp table, and each of those accesses requires a latch, an exclusive latch things are going to run into contention because they're going to be trying to hit those same pages. So flip back over, and we are now complete with the O stress. And let's see, it took 1 minute and 50 seconds to run. So what I'm going to do now is I am going to enable TempDB optimization. I run this command file. Once again, it's going to turn that setting on, and it will stop and start the service. Once that finishes, I'm going to execute OStress again with the same number of users and the same number of sessions. And while that's running, I will talk you through how the in-memory processing works. Okay, so this is where I'm going to cross my fingers because this is the part that was failing earlier. And it is failing now, and I have to figure out why it is failing, but I'm going to stop that from running. And what you would have seen had that run successfully, and you can trust that I don't have anything up my sleeve, when I ran this query again to see what page latch weights I had, I didn't get any results back. And the reason for that is that there are no pages to latch in memory. What I would have seen, though, is that this query will pull back a list of memory optimized objects. And these are all objects in TempDB that are now in memory. And this schema object is the metadata table that is written to when temp tables are created and then deleted. And so you would have seen these numbers continue to go up. So just to explain how that works, or how SQL Server does this, is instead of pages, when you have a table in memory, instead of that data residing in pages, you are now dealing with individual rows. So each row in the table is written into memory. And that row has a structure with a row header and then the row data associated with that page. And that row header contains a number of different pieces of data. The two most important ones are the start timestamp and the end timestamp. You also have the statement ID of the statement that generated the row, and then information about the indexes in that row. But what happens is I do an insert into an in-memory table. My start timestamp is the time of that insert. And then for a row that has been inserted but not modified, my end timestamp will be high values. And in this case, my statement ID is 1. So then if I update that row that has been inserted, my end timestamp for my inserted row gets switched to the start timestamp of the update, and then the end timestamp of my update is that high value. And what this allows SQL Server to do is if somebody comes in to access this row with a timestamp of 60, because 60 is between 50 and 90, it's going to hit this row. If somebody comes in with a timestamp of 120, because 120 is greater than 90, it's going to hit this row. And you'll hear this referred to as optimistic concurrency. In the standard world of SQL Server, where things get locked and latched, that is known as pessimistic concurrency. So this is how SQL Server is able to do that. And I don't have the numbers because I wasn't able to run OStress the second time. But OStress, the process will run more quickly with this enabled. So this is the second feature. You got ADR, you've got in-memory TempDB metadata. So those are the first two features I wanted to talk about. And the last thing I want to talk about is persistent memory. And this is a hardware change or a hardware improvement. And SQL Server 2019 is now set up to take advantage of it. And just kind of at a general level, before persistent memory, RAM is transient. So you have memory on your server. Anything that's written into that memory when the server restarts, that will all be lost. And this is why the transaction log buffer is flushed to disk on every commit, because the log buffer lives in RAM. If it doesn't flush it out and the server restarts, you're going to potentially lose transactional data, which you can't have happen. And because of this, SQL Server, when it goes to flush log buffer to disk, it's got to wait until that flush completes. So the confirmation has to come back, and this allows that redo and undo process to take place. And just to show you what this looks like, so I've got my data file, I've got my log file. I read a page from my data file into my buffer cache. I make an update to that page, and the log records associated with that transaction are written to the log buffer. On commit, those log blocks are flushed out to disk, and then the transaction commits completely. And then at some point, a lazy writer process comes through and writes that data page back to the data file and disk. With persistent memory, what persistent memory is this new technology that is effectively RAM with a battery on it. And so when your system shuts down, that battery allows the RAM to persist what was in there. And so the data that's stored in RAM can survive a restart. And this provides a couple of different opportunities for performance enhancements. The first of them is the persistent log buffer cache. So if you put your log buffer, and you can tell SQL Server, I've got one of these persistent memory sticks in my server, put my log file there, my log buffer there, that log flush is no longer necessary on commit. It can happen in the background, just like the flush of the data pages does. So then that persistent buffer is processed with the log file on a restart. So if you remember back to the crash recovery slides, it basically just appends the log buffer onto the disk-based log file that it's processing and runs through that recovery process. And the way that this looks, or how this looks, is got my data file, I read a page from disk into my buffer cache, I run my update, and my update's written to the log buffer. But I don't have to, I can commit the transaction, and those log records don't have to flush out because of the fact that this log buffer is going to persist with persistent memory. Then there's a lazy writer process that will later flush those log blocks to disk, and then a lazy writer process that will flush that data page back to the data file. The advantages of this are because log buffers aren't flushed to disk on commits, it will speed transactional processing. Basically, commits can happen as effectively fast as they do. You don't have to wait for that recovery. And the sort of practical result of those log buffer flushes is, if you've ever seen log write waits as a wait type for a SQL Server database, that's what a log write wait is. It is waiting for that flush, the acknowledgement of that flush, to come back. So that is the first advantage of the persistent log buffer cache. The second one is what is called the hybrid buffer pool. And I believe it was SQL Server 2012, they introduced a feature called buffer pool extension. And we talked about the buffer pool where these data pages are being written. That has a finite size. You can only put so much RAM in your server. So if I have a 2 terabyte database and I only have 1 terabyte of RAM in my server, I can't read all of my data into the buffer pool at the same time. And what buffer pool extension allowed you to do was to install an SSD drive, a fast SSD drive in your server, and you could tell SQL Server, okay, use the SSD drive as an extension of my memory. Now that's not as fast as memory by a long shot, but it's still faster than having to go to a traditional disk and pull data back into memory. So what hybrid buffer pool does is it extends that idea and puts the buffer pool extension onto this persistent memory. So it gives you the advantage of BPE. It allows you to extend the size of that RAM without the I/O overhead of the SSD. A couple of things to note here. PMEM is not as fast as traditional memory. So if your entire database will fit into RAM, so I've got 1 terabyte of RAM on my server and all my database is only 500 gig in size, this is not going to buy you a performance improvement. But if you're in the case where you can't put as much RAM as databases on your instance, this can be a performance improvement. And then the final thing I'll talk about in terms of PMEM is what is called Enlightened I/O. Now, this is a Linux-only feature, and as you probably know, SQL Server will now run on Linux, and this can only be enabled in Linux. And what this allows you to do is place your data and log files directly on this persistent memory. And in Linux, this allows you to bypass the file system and the storage stack when you are accessing data. So it's actually just going straight to memory. And so it will speed things up considerably. Once again, because PMEM is not as fast as traditional RAM, this won't buy you anything if your database fits into memory. But these are all things that you can do to leverage these persistent memory modules. So with that, I will explain that I don't have a persistent memory demo. And this screenshot is a couple of weeks old, but the reason why is this is a page from CDW, and this is for a single Intel Optane persistent DDR stick. So this is 512 gigabytes in size, and it, as of about 2 weeks ago, was just over $19,000. So this is not a hobbyist's hardware. This is something for a very kind of high-end OLTP system where milliseconds and microseconds count in terms of transactional processing. But if you are in that kind of an environment, this is something that you may want to look at putting into your servers to speed up the processing of your databases. So that brings me to the end. Just to review what we've covered, talked about the transaction log and transaction log architecture and how accelerated database recovery changes the crash recovery process. Talked about in-memory tempDB metadata and how that reduces contention that remains after you expand the number of tempDB data files you have to get around that metadata page contention. And then finally, persistent memory, how it's used for the persistent log buffer cache, for hybrid buffer pool, and enlightened I/O. And then I've got a number of resources. The slides and scripts are on my GitHub, which is github.com/screebydba, and they are in a folder called, or a repo called Minnesota Presentation, because I did this initially for SQL Server User Group in Minnesota, but they have been updated, so what you are seeing is what is up there now. These are Tiger Team materials, and these are a series of scripts, and there are slides as well from the Tiger Team, which is the SQL engineering team at Microsoft, and the demo code that I've run through has been modified from demo code that was built by the Tiger Team. And so those original scripts, along with a lot of other information, is up here. If you're interested in SQL Server internals, this goes through the internals of new features in 2019. And there's also a lot of really good information if you're interested in other Azure data features, machine learning being a major one. There's a lot of great information up here from Buck Woody. This is the Microsoft doc about hybrid buffer pool. And then more information about accelerated database recovery from a Microsoft documentation perspective. And then if you are an internals geek like I am, this is a white paper that was written by the engineering team that gets into the internals of accelerated database recovery and how it's actually working sort of at the log level. This refers to it as constant time recovery because it's Microsoft and we can't have one name for a feature. And then finally, a link to more detailed information about in-memory TempDB metadata. And there's a really great short presentation here from Pamela Hood, who is the program director for TempDB. And she does a really nice job of explaining it. I learned everything I know from her. So you can go to the source. So with that, I don't have any more slides. Simon, do we have any questions? Or is everyone just...
Yeah, Frank.
All right,
there are
great.
a couple of questions I'm going to drop in. You can come back to StreamYard, and I'm going to pull them on the screen.
Great.
Okay, starting with, let me go ahead and, okay, I have to find where did it go? Dun, 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 dun. Okay, here's the first one. Is there any scenario where a new transaction can lock the row being updated from the PBS rollback?
No. So because it's a version store, if you have multiple changes that happen, you're going to get multiple rows in the version store. And that's something that I should have mentioned, is that I said that because of the way persisted version store works and allows SQL Server to truncate the log more frequently, your log file will be smaller, but your data file will be somewhat bigger because the persisted version store does take space in the data file. Because it is a database level feature, you're going to write those rows into the data file. And this is something you need to test. All the testing I have done has shown that growth of your data file is much smaller than the growth of your log file without accelerated database recovery, but you need to test to make sure that in your scenario it will do the same thing. But to answer this question, no, you're going to get multiple versions. So I insert a row, somebody updates that row, somebody else updates that row. I'm going to get multiple. Those versions will all be in the version store, and then as they are no longer needed, they'll be cleaned up.
All right, definitely. So we'll now move to the next question that we have is the accelerated data option comes in SQL Server 2018 version and up.
2019. There is no 2018. It's 2017 to 2019. But yes, 2019 and up. So if you're running a database in Azure, either Azure SQL Database or Azure SQL Managed Instance, it will be available there. And then if you have SQL Server 2019 bits installed on an on-prem server or a VM, it'll be available there.
All right, so we'll take like the last question, that is, does TempDB optimization in memory create multiple virtual TempDB files then release once?
No. So because of the way that in-memory works, you no longer have data files. So in the traditional world, I've got my data files for TempDB. Those are resident on disk, and then the pages from those files are read into memory. When you turn that in-memory switch on, you're no longer using, and it is specific to these table objects. So what I should say is that you're still going to have those files. So TempDB is going to use those files for creating the data for your objects. What is in memory are these metadata objects. So that sys, I believe it's sys.schobjs is the one that I showed you. That's a table in TempDB that SQL Server uses to track where these temp objects are allocated. And that is what is going into memory. So it's not going to affect your TempDB file structure, and it doesn't create any additional files. It does all of this stuff in memory. So I hope that answers the question.
Yeah, so I think that's it. We're gonna end this over here, and
Okay.
we'll move to the next session. Frank, thank you so much for your time. We really appreciate it. It was a really great session, and we'd love to
Thank
have
you.
you back again.
All right. Well, I would love to come back, and thank you again for the opportunity. I will stop sharing and log off. So have a good rest of the day. All right.
Bye. Nice weekend. Bye. All right, with that, we move to our second final session, and that is by Steve, who's going to talk about DevOps through the database. And I definitely believe it's going to be a really interesting one. So let's go ahead and have our next speaker, Steve Jonas. Steve. Welcome to the SQL Server Virtual Conference.
Thank you. Thank you. Thank you very much for having me. And that's a great little introduction you have.
Yeah, thank you. And thank you. I know you are from the Redgate team, and Redgate is the sponsor for this conference. So I really want to thank you for all that Redgate does for the community. And we now know that Redgate did a recent acquisition for a good community for the SQL. So thank you so much. We really appreciate for all that you guys are committed to the community, and really honored to have you, Steve, and looking forward to your session.
Thank you. Thank you. And, Redgate, we are happy to support you and the community. And so we'll continue to do so.
Thank you. Thank you so much, Steve. I see your screen. I'm going to add it to the stream now.
Okay.
And next 45 minutes is all yours.
All right. We ready to do this now? I guess we're just a couple minutes early, but let's get started. So welcome, everybody, to the C# Corner SQL Server Virtual Conference. I'm first one of 2021 for me, and I'm thrilled that we're actually back to doing some of these things. And I'm looking forward to this. So today I want to talk about bringing DevOps to the database. And really, I've got 3 takeaways that I want you to get here. The database can be built, tested, and released like other software. I think a lot of times we look at the database in one way, and then we look at application software or mobile software, whatever, in a different way. And there certainly are differences, but we want to think about the similarities as much as possible here and learn from what software developers, what application software developers have done that can be applied to the database. And that's really what I'm trying to do today. Now, I've got some the agenda here is I'll introduce myself a little bit, give you some principles of DevOps just so we kind of level set what's going on, and then talk a little bit about the way we might do software development in DevOps, and then how the database fits into this. So please feel free to ask questions. I'm trying to give you one way of doing this, and I'm not trying to say this is the way you should do it, but this is at a high level, conceptually, you want to follow the things that I'm doing. The actual tools, technology, platforms, et cetera, that you might use could vary, and there's really no one way to do this. So as Simon mentioned, I'm Steve Jones. I've been doing this a long time. I've been 30 years with SQL Server, actually, since 1991, which is crazy. But in that time, I've worked for a variety of companies and industries. I've been a DBA and a software developer, as well as a database developer. I've managed both groups. And then I've been a writer speaker, for the last 20 years, really, as part of this. I founded SQL Server Central years ago with a bunch of partners, and I'm the current editor now, and I run it. Redgate purchased SQL Server Central about 14 some years ago, and they've continued to support the community and provide this resource. And we hope to continue to do that with some of the other things that we acquired from past recently as well. And then Microsoft honors me as a data platform MVP, which I'm proud of as well. I've got some contact information here. Please feel free to reach out to me if you want to. I'll have this at the end as well. So I like to just level set briefly about DevOps, because a lot of times I find SQL Server or relational database people don't do a lot of software development, especially if you're admins, and they don't know what DevOps is. And I'm not sure I completely know what DevOps is, but I want to give you an idea. There's this seminal talk that came in the Velocity conference in 2009. So we're talking, 11 years ago now, where Flickr said they did 10 deploys per day. Now, I work with a lot of customers and clients, and I don't know many of them that deploy anything 10 times per day. Forget the database, right? But just software, they don't do 10 deploys per day. I do have some that may do a couple per day, and once in a while they include the database in there. And I certainly have customers that deploy the database multiple times per week, but 10 times per day is amazing. And that was 11 years ago. These days, there are companies that are certainly better. Amazon releases every few seconds because across their thousands and thousands of developers, they have typos, they have style changes, they have database changes, and they have other things that get released kind of constantly. And the idea of DevOps really is its principles and ideas, and not really prescriptive things like Agile or Scrum or some of the software methodologies we have out there. Now, there's been a lot of work and research. Gene Kim has been one kind of in the forefront of this in terms of talking about DevOps and really better ways to build software. Now, I've listed 3 books down here. I list them in this order because it's the order I read them in. But the Phoenix Project and the Unicorn Project are by Gene Kim with a few others. And they are novels. They're essentially easy to read novels. They're short, but they're based on IT. And the Phoenix Project, it's kind of the ops side of DevOps. The Unicorn Project is kind of the dev side of DevOps. But they're kind of based on this book in the middle called The Goal from Dr. Goldratt, which is about the theory of constraints in manufacturing. And it's a novel as well. I think it's actually the best of the 3 books, but they're all very interesting. And they all give us these ideas of flow, feedback, and then experimentation and learning. And those are really the principles that we are trying to adhere to or follow in DevOps. So in flow, we think about the entire process of building software. So we start, from the time there's an idea that says we want to build this thing, whether that's, a Tesla, whether it's an engine, a power plant, a wooden table, or it's a piece of software. And then we think about how can we get that all the way through to the customer kind of as quickly as possible, right? Or as smoothly as possible. And so we don't have a lot of time spent in intermediate stages if we can avoid it. That also means we don't necessarily optimize the intermediate stages, right? We don't optimize development or QA or something else. We optimize the entire flow. We think about trying to get everything out to our customers. Feedback is, of course, understanding what happens, the impact of things that happen. And in software, this really takes 2 forms. So one of these is the quality of what we've done, right? The quality of the C# or Java or Python code or SQL code. The other thing is how do we move those bits from one machine to another, because we are moving between systems here. So we give feedback between various entities involved in the software process so that we better understand how we can improve both of those things, quality and the process of moving software around. And then lastly, we want to have this culture of experimentation and learning. Most of us get paid well because we have a lot of knowledge. We do things very well and experience. We have this experience, but we want to try new things over time. While I would say that a lot of the relational theory and database development stuff I do now is the same as what I did 30 years ago, there are differences, and there are certainly patterns in how I deploy changes and how I might actually architect things now that are different. And so we want to make experiments in both ways, right? In both the quality of how we build software or maybe how we write queries and database structures, as well as how we move those structures from one machine to the next. Okay. And then the learning piece is we have to make sure that everybody adopts the things that work well. So we have patterns. Everybody starts to use those patterns. We have anti-patterns. We avoid those, which is a very difficult thing because we get caught up in doing what works well for us, what we're comfortable in. And so we want to find ways to use the best of what we've learned over time and share that in our organization. And then these are the 3 things in DevOps. They're talked about in these books, and I highly recommend all of these books. So in practice, there's lots of ways to look at DevOps. There's lots of people talk about it, besides me. But there's this acronym called COMS. And COMS is Culture, Automation, Lean, Measurement, and Sharing. Now, of these items, right, they're fairly self-explanatory, right? I have some minor items in here that try to explain what they are. The 3 in the middle are much easier to do. The automation, we can introduce tools to the database and do all kinds of comparison stuff. We can certainly make changes simpler and easier, though this is actually a challenge for a lot of people. They don't think about this. And we can certainly measure the impact of our changes, right? Am I using more reads? How long does it take to deploy this? Am I creating locks? There's all sorts of instrumentation that we can gather on our database. Those 3 are relatively easy, but these first and last one, the culture and the sharing, are actually the most difficult things I find in most customers. Those are the things that truly require people to change, and they make things take a long time. The culture of people working more closely together, not necessarily just DBAs and developers, but often I find that teams of developers working together is really a challenge in a lot of organizations, especially enterprises. Even when they work in the same database, just coordinating with each other is hard. And then sharing the impacts of things and acknowledging or understanding or having empathy for what somebody else is doing, their pressures and deadlines, the impact of their changes on you or the impact of your changes on them is very difficult. right? And apart from just even changing how we do things to adapt to each other, just understanding and appreciating that is very, very challenging. So a lot of customers I find want to buy something from Redgate or someone else, introduce automation and measurement and do kind of these middle things. And they forget that both for the people doing the work and management, the culture and sharing pieces are extremely important. We're going to talk about kind of the middle section today because I could talk culture, but we don't want to do that. We want to see some tooling and other things. So let's talk about DevOps pipelines here in terms of moving software. So I've got a diagram here, and let me grab my little pen here. So if we say on this side, this is development, right? If that kind of looks like a D, and then production over here. And what we're trying to do is we're trying to move bits and software this way. So let's just say this is C# stuff that we're doing here. I have a bunch of developers. They'll write code on their machines. They'll use some sort of version control. I think Git has kind of won, though in the Microsoft space, there's certainly still TFS, VC being used. But they use version control to centralize development. And then most of the people I know doing software these days have some sort of automation in place. This is typically this continuous integration cycle where a server of some sort reads out of version control, it does a build, it does a test, it reports feedback back to developers, and I'll show you a little bit of how this could work. And it just kind of runs in this cycle every time there's a change. If things work out well, there is this sync step where we capture an exe, a DLL, a jar file, whatever types of things we're outputting from our software development. And then often what there is there's some sort of release process that involves an automated server that shoots bits to the various places it needs to go, right? So all these downstream environments get filled up with bits. Now, for most of the people I know in database development, they don't quite have this same pipeline. Right? This would be kind of the ideal DevOps pipeline or software development pipeline for databases. But what I find is a huge number of developers don't really use version control, and they often work on one database, not individual databases for each other. They do communicate, they get things done, so it's not horrible, but it's work, right? And it's an inefficient way of doing things. Most of them don't have continuous integration, and most of them don't have a release management process. Instead, what they typically have is they send stuff to a DBA, right, on a file share, an email, or whatever. And then the DBA releases that to QA. And then the DBA has to release again to staging or UAT or production or something. And they may do it in different ways. They may see a fix or they may see an optimization. And we end up with a disparate process between each of these environments. Now, don't get me wrong, this often does work, though DBAs often spend many hours or many more hours than they need to get all these releases done. And they make mistakes. They can fix them, but we don't want to make mistakes. And we don't want to depend on the quality of somebody's intellect. We don't want to depend on Steve's intellect and skill every single time we need to do a release, because if I do 1,000 releases, Steve's going to make a mistake somewhere. And once in a while, one of those mistakes will be here where it will actually be critical and it will cause problems. So what we want to try to do is get back to that pipeline that we had for software where we have automation and we have processes in place. So if I think about changing how I do development, there's a number of things that I try to aim for. And again, these are kind of high-level concepts. I'm not telling you how to do them, but I'm telling you these are things we want to do. The first thing I see is that we really need consistent environments in development. I see often problems introduced at client sites because one developer sees something different than another one, whether that's schema or data. So we want consistency. We want to be able to onboard people quickly, because it shouldn't take me days or weeks to onboard a developer. It's actually amazing to me, places I've gone where it takes a week to get a developer set up with an environment and a machine and all that stuff. It should be really minutes to do this, right? Maybe tens of minutes, maybe hours of minutes, but it should be minutes. We also want to have consistent data sets. And I see this a lot of times that bugs slip through and we have problems with queries or we have problems with logic because we have inconsistent data sets between developers or even between different releases. And what we want to try to do is have consistency here, especially between developers and downstream environments like QA environments. ultimately, for me to test the use cases, the problem domains that I'm looking for, I want to have something consistent. And then I want to shift left. And left really goes back. Let me pop back to this diagram. Left goes back to this diagram where this is left and this is right. Finding bugs here is bad. What we want to do is we want to find bugs here before it gets anywhere. And we want to do that by having some consistency. So we're trying to shift compliance and security left so that they find it earlier in the process. It's quicker, easier, cheaper to fix all those things. And then compliance is a bigger deal. Now, I know some of you are all over the world, probably plenty of you are in America because we're on the American time zone here, or at least North-South America. But this is becoming a bigger deal for a lot of my customers and clients overseas, from Australia to Japan to the EU. Everywhere, protecting sensitive data is a big deal. And a lot of the breaches and problems we have with data come out of development test environments, non-production environments. So the things we want to typically do is protect the sensitive data, and we do that, mask, anonymize, pseudonymize, et cetera. And then often we want to know what to protect, so we classify data in production. This is actually becoming a bigger deal. Redgate's done a lot of work here in the last few years. Microsoft just has their Azure Purview product. There's Informatica and lots of other things as well, but this is becoming more important, and it's going to continue to become important because more and more governments and regulations are impacting our work. So at a high level getting started, the next place that's really important is version control. And the foundation of everything we do in software is version control. I'm truly stunned that it's not 90-some% of people everywhere using version control. Instead, even in application software, I think the latest surveys show 80-some%, high 80%. In the database side of the Redgate, when we do the state of database DevOps, we typically find 50 to 60%. You've got to know what software, what versions are out there, especially if you're going to have efficient development. And I don't know how to say it other than you couldn't work for me if you didn't use version control. It's just that critical. Okay. The application people have been really good at this process over the years. So treat your database code like app code. Right? I don't want to get into version control too deeply, but people always ask these questions. Do I do one repo for the app and database, or do I do two here, or three or four, or whatever? I prefer separate, but this is a philosophical argument. I think that a separate repo means that the database is a first-class citizen. And by that, I mean I have a Git repo for my database. I have a different Git repo for my application, different Git repo for my report application or mobile application or something else. I like to have things separate that are first-class items, but it's up to you to do it. The one thing I would do is say use a subfolder for your DDL, because often what I find is that there's various test scripts, smoke tests, things like that I want to capture near the tables, views, procs, et cetera, but I don't want it in the same place. So I kind of go subfolder, and I'll show you an example of how I can capture code. I'm not trying to say this is how you should do it, but you capture however you want. My Redgate does one way, SST does one way, other products do different ways, other tools that are paid for, open source to it, just use it, okay? I would do what my app developers do. I think Git has won, but do what they do. Keep it the same in your organization. We used to have like 4 different systems at Redgate, and it was silly. We just standardized because it makes it easy to move people around and find stuff and tooling, everything else. The last thing about version control is that be really careful with branches, especially in the database. Redgate, we don't allow branches to live more than 7 days for our app code. If you've got something out more than 7 days, we're like, you got to re-pull back from wherever you got it from, because we can't have stuff diverging so far that it's difficult to merge. Because the database is foundational in a lot of applications, you want these super short, like really, it should be hours. If you can't figure out what schema and thing I want to do, immediately just go pull back the next version of the database in case something's changed, and then work again. But just be careful with branches. Okay. All right. So I'm going to talk relational databases and SQL here, but it's not terribly different. Really, what we're trying to do is we're trying to get our DDL and DML into a version control system, which is typically a text-based systems. So what we typically want to do is we'll write code, we'll put it in a text file, commit it, and then comment. That's really the process. It's not terribly hard. I guess these two are slightly reversed because I comment before I commit, but you get the idea, I think. There are lots of options for how to do this. I'm going to show you one way. I'm not recommending it. I'm just saying this is a way to do it. The key is I need to do this step here, right? I need to capture the DDL and text file to commit it. That's what I want to do. And then just like the application, folks, I'm going to use pull requests. So let's see that actually happen here. I've got a database here. And as a matter of fact, let me just kind of show you this. I've got multiple databases here. And what I'm going to do is kind of flow code in this way, right? So I'm going to go from 1, 2, 3, 4, 5 across these databases, but I don't want to touch anything other than database 1. So I'm in database 1 here. I'm going to create a table. So I'll create this table, C# test. There's nothing magic about it. And then what I want to do is stick it into a text file. So I'm going to say this is a demo test 203, I think I want. And I'm just going to show you this. Down here, you can see that I've got code here. This is my database. Make that a little bit bigger. Here's the code I wrote, essentially. This is a database. This is version control. There's nothing in version control. So let's commit this thing. Now I'm using Git here, so I'm going to have to push this out to a remote repository. If you're going to use things like Git, hey, baby, my little doggy's not very happy today, but we don't want to keep code on our machine too long. We want to push it where everybody else can see it. So I'll push this code out there. Now, this code actually exists out on, where is my repository? So in Azure DevOps, I've got a project here. Here's my, let me make this a little bigger, my DLM demo project. And you can see here, I've actually got 3 folders in here. So I've got a hello world because I do demo, app, and database code together. And then I've got this scripts folder, and this is where I'm putting all my database code. And if I refresh this, what I'll actually see is just now is that demo test that I put in here. And if I were to go through this and look, what I would see is my code, and the one I just did was a table. And so if I flip here, here's my actual code that I just committed, okay? So I've captured it in a text file and pushed it up there. I'm going to create a pull request and get this moving because automation does take time. It's working in the background. But I just realized I have a typo here. That should be a pound sign. But I create this pull request. I could look at it if I wanted to, see the files and changes and commits and all that stuff. But I'm just going to approve it and complete it. And you can see I have this kind of log of what went on, right? I created a pull request. I reviewed it. I approved it. If I was working in a team and other people do this, we can kind of have somebody else look at my code, which is a good idea because I make mistakes. And then they could decide it's good or bad. We'll let it in there, leave a comment, say, you know, best code ever, which is probably not true, but you see something in there. I get the idea. I get to track what's going on. And that way, especially in this remote world with the pandemic, if I'm trying to understand what people have changed and what's going on, I can kind of look through what's happening in my code. All right. That's not the one we want to see. Let's keep going and go to the next area of this. So I got my code, I've written it, and I pushed it into a place where everybody can see it in version control. Now I want to evaluate it. And so continuous integration has existed for many years as a way to validate and verify code apart from your machine. Right? I think plenty of us have heard the "it works on my machine" thing from developers. We don't care. It has to work on other machines and server machines in different places. So what we do is we try to build and test our code up, all right, and package it. And that's typically what applications do. This is the place where we start our initial look at the quality of our code and do compliance. For databases, this is slightly different than applications because we don't have a compiler. We don't get an independent compiler like C# has a command line compiler. Instead, what we have to do is follow the process that I've listed here. So I pull my code from version control. I have to order it because I get all these files, right? And in a C# project, the compiler will reorder the methods and the various classes into some way that makes sense. the SQL Server compiler, which is inside the SQL Server database engine that's running, doesn't do that for me. I have to do it myself, right? I can't create an index before I have a table. So I have to order this code. I have to run it on the database in Management Studio, just like the code I wrote. And then I can do things like run tests and package this code. The way that I do this is with something called a build server, okay? And that is a server process that knows how to assemble software. They're toasters, as my business partner would say. They all work the same, right? You may want a red one or a big one or a small one, but they all do the same thing. There's TFS, Build, or Azure DevOps. There's Bamboo. There's TeamCity, Cruise Control, Jenkins, Hudson. There's tons of them out there. Pick whichever one your people use. None is really any better or worse than any other one. Really, I don't think it is. Part of this CI process or this build is that we should test things. And to do testing well, you need to automate it. Now, testing was something for, from time I was in high school and university to, businesses, we talked about more than we did. But in the last 10, 12 years, I've been amazed how much testing takes place at the application level. There's a lot of unit testing as well as other testing that's automated. We can do that in the database as well. We should. And I'm a big advocate of doing database testing. Now, we all do testing, like we run queries and then we run some process, sort procedure, function, and then we run queries again to see if things worked. That's testing, but it's not automated and it's not repeatable or reliable. So what we typically need is a framework of some sort that allows us to have a known starting state and support transactions, because we're relational databases here, and then write and run these tests. I use T-SQL-T here in this demo, but there's plenty of other frameworks and ways to do this. It's just up to you, whatever you want to do. I do say, and this is something I've seen over the years with customers, that having a curated data set is amazing. Okay, having this in development and then have it to go through CI and then QA and everywhere else, it's phenomenal. Because most of us need to solve a certain number of problems. For example, I worked with an accounting system one time, and the customer, right, the CFO said, listen, there's 50 types of things we do when we record transactions in accounting. You have to solve those 50 things. Okay. Now, there's millions of copies of those 50 things in their accounting books, but there's really only 50 things that we need to account for. And that's what most of us have. We have a limited number of types of transactions or shapes of data that we have, and then we have those repeated millions of times in our databases. If we can get down to that curated data set, then we're more agile, it's simple, it's easy. We can adapt and maintain this over time. I've given you some ideas here what to do. I think this is the best investment you can make in your software development. It's a pain in the rear. It takes time to do this, and it's ongoing maintenance too, as your schema changes, as you learn more about your problem domain, to keep adding to this data set. But having a 2 gigabyte data set on a 10 terabyte database is phenomenal. I mean, it really does make everything you do easier and better. So let's see continuous integration. Now, in Azure DevOps, that's your pipelines. And I actually had continuous integration running. So if we look here 6 minutes ago, we had this run and it in fact failed. So let's take a look at what happened there. You'll notice it says it finished with errors in the test step. If I go here to tests, what I actually see is that of these 17 tests, one failed, and it was, I created a table without a primary key. Big fan of DevOps. Please do DevOps and version control, but nothing else. You should know that all tables require a primary key, like all tables. You might convince me very, very rarely, but for the most part, all tables need primary keys. So let's fix that. Just so I don't have to write code, this is how I would actually fix this. I would make a not null column, add a primary key. I'm going to make another change too while I'm thinking about it. I have this place where I keep data in here. So this is this RSS feed. So what I want to insert is C# corner here, and I think I need a 1 here, actually, in here. So I'm going to insert this data in here and then run this thing, and then I should see a new row here. Excellent, right? That's great. Let's get going in version control. So fixed PK error, added new data, and I'm going to say pound 204 is what I was doing. And I'm going to show you what that means in a minute. Here's my data change, or sorry, my table change. Here's my data change. Let's commit those. Let's push those out to a repository. There we go. And then if we pop over to our version control system, I see I fixed this error. Let's create a pull request. I know I'm going through quickly. You can rewatch the recording or send me a note. We'll do this. And what this is actually going to do, if I go back here and look at my pipelines, this is actually running right now. It's kicking off, and you see the timer here is actually running if you watch that. And if I go look at this, what I see is there's a number of steps here where I'm going to check out code and build it, right? This is just, git commands to pull out my code. I'm running a build and other things, all right? This is just a pipeline that I've created in Azure DevOps that has a series of steps that say do these things. If I wanted to add another one, most of these CI servers have something similar where I have all these tasks that are available to me and plenty of add-ins and things. So if I needed to, make a GitHub comment, or I needed to install a certificate or anything else, I can do all the stuff that I need to do to make this happen. Okay. Come back to my pipelines. And this takes, if you look, about a minute to run for most of these. And so what it's actually doing here, if we look at this, it's in the test step now. So the build is make sure that I can assemble all that code and compile it without an error. And then for the build, you'll see here, actually, this time everything ran successfully here that I had in place. And then we're going to build and export these results and everything else. The mechanism of how you do that is up to you. There's lots of tools, open source projects, paid solutions that do these things, right? That do a build and a test, et cetera. The point is you need to do those things in order to start to independently validate and verify your code outside of a developer's machine, okay? Once this is actually done, what we'll see is that I have an artifact here that I've actually published. And so if I look at this artifact, it would just give me a NuGet package that I could look at. And if I pull out my NuGet Explorer, you can see that I've got code in here. So I've got, where's my table? My C# corner table is in fact, C# test table is actually here. Okay. The packaging, all that stuff depends on what we're trying to do. So let's talk about that next. All right. Most of us are concerned about generating update scripts, to build a C# application. Normally I just replace an exe with a new exe, or a DLL with a new DLL, or whatever resource items I have. For databases, it's a little bit different. There is code there. So there are stored procedures, functions, views, modules, etc. I can take the latest version that I've tested, run through CI, and just put that on my next database, right? Run it. But for tables, I can't. I can't take a new create table statement and apply it to my database and have, an additional column appear in there, right? Or that alter where I changed the null to not null, or added the primary key. Instead, I have to use alter scripts to do that, which is crazy. It's why SQL is a crazy language. But in any case, I have to do something different here. There are fundamentally two different ways of doing this. So there's a comparison method and a migration method. And again, like the distributed or centralized version control or the repo structure, it's really a philosophical choice here. There are pros and cons of both these methods. But let me take a moment and talk about each one of these. So in the comparison-based method, it could be called the model or state or comparison process. You see I've got dev and prod here, and they're the same, right? It's got tables, views, etc. What I typically do as a developer is I write code. So I create a table, I alter a table, et cetera, et cetera. I do all these things. But in this process, I don't care what I did. I just apply that stuff to the development side. Now, of course, I want to stick this in version control or something else, but I just apply this, and then I run some sort of comparison technology. Redgate, we have SQL Compare. Microsoft has Schema Compare. There are various other tools that do this, but it looks at these two states of the databases and all the objects, and then it generates me a script that has the create, the alter, the drop, the whatever stuff I need in it. And I apply that to my database, and eventually then prod looks like development, right? This is a very simplified view, but that's what we're really doing in this model state comparison method. In the migrations process, it's a little different. So I've got the same, starting place here. And as a developer, I still do these same things. I write the changes that I care about and want to run. But now, once I've applied it as a development database, what I actually needed to have done before I closed, Management Studio or Data Grip or whatever I've used, is I wanted to save each one of those scripts in some orderly fashion. Now, I've shown them here with a numbered name, which is very common, but there's a variety of ways of doing this. I just need to know what order I ran them in. Because what I'm going to do is I'm going to rerun those scripts against my prod database, and this should say, prod here, to make the changes and make it look like the development database. As I said, these are really philosophically two different ways of doing things, and there's no reason to pick one or the other unless you have a specific reason. Lots of people love the state model comparison method. It's simple for developers. They don't have to track anything because I'm capturing the state of things. Merges are really easy to do. The tooling generates my scripts. I see all the history for objects, et cetera, et cetera. The cons are there are certain problems I can't solve by looking at the beginning and end state because there are multiple paths to get there, and some of those paths are not good. Let's say I could lose data. They could be problematic in terms of how the tool chooses to implement the change. The ordering of changes sometimes is problematic. There are just limitations here. If you do very simple types of development, very standard types of changes, the comparison method works fantastic, and it is simple. But there are, there are edge cases and problems. Migration, on the other hand, is a little different. It's absolutely bulletproof because everything that worked in dev test works in production because it's the same thing, right? I'm replaying in the same order and same changes, which is great. I can do any type of change that I need to, and I can control the way that we make the change. So a lot of especially advanced database developers and DBAs like the migration method. The cons are you got to track everything, right? It's hard for developers, and merging stuff is difficult because if I have 6 alter scripts that work on the same table, what order do I want to run them in? You might not care, but you might, because if one developer has added the Twitter ID and then the LinkedIn handle in that order, and the other developer had LinkedIn first and then Twitter. It's not a big problem for most platforms, but it certainly makes some people crazy. And you might find somebody trying to rebuild tables or do other things. And not only that, sometimes the changes I make, the chronology matters, so I can't necessarily automatically merge these things easily. The other big problem is that everything that happens in dev happens in production. And so, adding a column to a table and changing some data is not a big deal when I have 10 or 20 or 1,000 rows in my dev database. But when I have 1 billion rows, it can be very time consuming. It can be problematic. So the way that I make those changes sometimes is an issue. I actually worked the migration method when I worked with Oracle databases, and literally spent like 50 hours one weekend migrating an Oracle database because all the scripts had to run in order, and they just took time because of our volume of data. The key, though, is whichever process you use, you want a consistent way of deploying your code. So whether you use compare method or you use migration method, I want to have a consistent process, and I want to use as much automation as possible. There may be a need to have some manual steps, especially as you start to try to understand your process, but we want to limit those as much as possible. And I'll show you one in my process, actually, where I have something there. The key is everything I do manually, I want to slowly and continuously improve and automate. And that's really the philosophy here that I want to tackle. Now, I want to use a release management server to do this. There's pieces of software that are designed to move bits from one machine to the other. Again, like the CI servers, there's tons of them out there. Pick whichever one you want. Doesn't matter. Okay. All right. Let's see releases here. So I actually had, if we looked at this pipeline, let's see if that completed. Hopefully it did. Yes, it did. So my primary key error didn't pop up again. I have this release thing set up as well. You have a few different processes here, but this is the one I'm looking at, and I was testing it earlier today, and it worked fine. Released everything. So let me actually just create a release. Let's create a release, and let's actually hit create. And this will start running. It's saying release 96 is queued. And if I look at this, what I see is, here's my process. My artifact from my CI build, if you were looking at numbers or you rewind the video, it was 1166. I triggered it manually here. It's now releasing to QA, and it's going to go everywhere else. Just to show you what that looks like, if I come back over here, we had the select from RSS feeds. I have, C# test. I have this integration database where I have C# corner and I have that table. They exist because part of my build step was actually to integrate this into a spot with all my other code. But in the QA area, I don't have C# corner and I don't have that table. Likewise for my staging, same thing. For my prod, same thing. And if my Azure database is alive, say same thing perhaps. We'll see if this runs. This is actually a serverless database, so I think if I've taken too long since I last accessed it, it's gonna have to start back up. But we'll let that run while those things are going. My QA process actually succeeded, and my staging process needs an approval. So there's this manual condition I had in there to say, do this thing, and I can put stops in my process to say, notify somebody, ask them to click something, do review something, do all the things that I want to do. So these all run, and you can see that I haven't actually connected and tested any of those databases in terms of running code. But if I were to come back to, boy, Management Studio appears to have frozen. Let's see if, it's back, okay. Here's my QA. I have C# corner in the ID. It should be here. And I think it takes about a minute to do each one of those that exists. We'll skip Azure for now. But I didn't touch this database and do anything, but that code got deployed out to this QA database. Okay? And it's going to continue to run to the other ones that we could check. Just to show you this process, it looks very similar to what my build process did. I have these various stages where I just pick steps and I say, do this, 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 whatever things I want, I add them to my list and I run them. So I can kind of control how this works, but I can create some consistency in how I deploy things. So in this case, I have variables for names and passwords. So a developer could actually use this without knowing the password to release. We don't connect to the wrong machine because it's programmed in here. And in these tasks, it says, connect to this database, to this instance, et cetera, et cetera. So by having this consistency I reduce mistakes and I reduce the burden on somebody to do things manually by letting the computer do what I would normally do because I've just programmed it in here as a process. And this is the thing I say, you continuously improve this process over time as you learn how your system best works, okay? So this is in staging. It succeeded there. We'll just let that run in production just so you see here, C# corner, and that table does exist. All right, while that's running. This isn't perfect. It's not super necessarily simple and easy. There are issues. Rollback is something I hear all the time, and I don't have great solutions here. And as a matter of fact, most of the tooling I see doesn't have great solutions. For code, it works really well. Anybody's tools work well because I just take a different version of the text file for a view, a proc, or a function, and I rerun that, right? I can use create or alter in most systems now, or even if I had the alter script for, last version of code, that would run. Tables are different. Tables need custom code. It's easy to say, well, if I added a column or added a table and there was a problem, I drop it. I got to tell you, I've released code for databases for decades. A lot of times I don't find a problem right away. I certainly do have problems sometimes with actually compiling that code, but in this case, I wouldn't have it because it wouldn't have compiled on QA or staging. Typically what I find is I find a problem later, especially logical problems, minutes, hours, days later. And so I don't want to roll back to the previous version. It's complex when data is involved. So I typically look to write specific rollback code, scripts for risky tables. And risky tables are things that make my phone ring, that things that might affect my job here. But for other ones, I usually just fix on the fly and I just roll forward. Okay. I do like a separate DBA pipeline for rollbacks because I don't want something to actually accidentally run through there. And depending on what technology you might use to help you do this stuff, you may implement it differently. But in general, I'm a fan of dark deploys, meaning I make database changes that nobody knows about, the application doesn't know about, customers don't know about. We run some tests in production, we think it's okay, and then we'll turn it on with feature flags or feature toggles. So that's what I think. Also, for things like SQL Compare from Redgate, I don't trust them to do table data rollback because it's my job a lot of times. I can't lose data. You could feel differently, but that's how I feel. There are also other issues. So there's data that varies by environment, like email server names, queue names, CDC. There's various items that are just, they're specific to environments and they're problematic. I've never found a good way to do this other than have two people look at it whose job depends on it. You can use tokens, you can use all sorts of things, but these are issues that come up and I've never really seen a great solution other than, two people review it, don't make typos, whatever. This is a cycle, right? So I showed you kind of this, left to right here, right? Where this is production and this is dev. But really this is a circle because we have to feed stuff back here. Okay. There's data that needs to come back to development of items for refreshes. That's a part of this stuff. So there's various things you need to do here to make this compliant with GDPR or Australian data privacy or Japanese privacy, whatever, right? And you have to maintain this as part of the development process. I'm sorry for scribbling all over the machine, but you do have to maintain this. But it is something to think about as you move forward. All right, before I pop over here, let's real quick look at this. Everything, see, it actually got to my Azure database as well. And if I look there in prod, I should see C# corner, and I do. Fantastic site. My table's there. And in Azure, did this actually work? It's disconnected. Oh, no, it's there. So in Azure, this actually worked. And this is my server in Azure here. You could see. So I've got this code to go. Let's close this. From this area to this area, I don't have my Azure one here, but across all these databases by only making the changes in one database, but having it flow through my process. And the nice thing about flowing through this process is if I wanted to know, let's say to production, what happened, I can see everything that happened here, right, in terms of the timings, and I can see the logs of all the different things that went on. But in terms of the overall view of what happens, I also kind of know what types of changes were involved, right? Because if I were to go back and look at this CI build, this would tell me this actually passed all these tests and things, but it's also linked to work. And so I could come over here and I could say what item or what request, what triaged piece of work was this? And here's my board where I'm tracking things. This is the board actually where I've made one for C# corner. And I have these tasks in there, okay? And these different tasks exist. In this case, 204 was change data. And I can actually link that back to the development work and then the release, the CI build and the release that actually included this, so I can understand what's happening to my software at any time. And certainly project managers and management and business people can look at this as well and track where their work is and when it was released and all that other stuff, all of which simplifies the world for developers. So in summary of this, right, I've given you kind of this way you could do DevOps, right? By kind of doing the flow, right? Systems thinking, the feedback, experimentation and learning, right? I made that mistake of primary key. I want to make sure nobody does that. We set up a template or a snippet or something to prevent that. But I'm not telling you how to do it. I'm just saying we want to do it. We want to follow these things and make this happen. We want to treat the database like application code. So I'm using CI and release management and version control and all the things that application developers are really good at. And then lastly, the best part of DevOps is I want to learn and get better. So I want to do more of what works and less of what doesn't. I'm adapting over time to become better at building software, both in quality and how I get it from one machine to the other. So that's my summary today. Here's my contact information. Please feel free to get a hold of me. Simon, are you around somewhere? We have questions, comments, complaints.
Not complaints, Steve, but we have a comment coming in from Mahesh, who is the founder of C#. He says, "Thank you, Steve, for using C# in your sample. You are a rock star. Hope to get you back on the show sometime again."
Yeah, I'd love to. And, I certainly could brush up on my C#, so I'll be spending some time there.
Oh my goodness. Okay, so I think I'm going to pop some questions on the screen. Let me know if they are related to the session. Kay Vanron, okay, I hope I said that right. How much of your changes are being documented with comments within the SQL code versus documenting it within GitHub?
That's a great question. So I think this really becomes team specific or organization specific when you think about it, because I am a big fan of comments in the code for how it works, especially when, like regular expressions, I can never decode regular expressions. And if anybody ever commits code regular expressions and they haven't explained it in the code, it makes me insane, right? Because it's a project for me to decode something like that. Or sometimes I see that with Python iterators or lambdas.
Yeah,
I don't do it enough, so it's really difficult. So in the code, I kind of want to explain complexities that might apply between different levels of developers. Mm-hmm. The comments in version control are kind of the business of software of why did we do something, right? Not what we did, right? Because at any point in time, I make a change, and maybe I can, if I were to go through version control and look at this, right, in my history, let's just look at a file. What I could actually see is that there is various changes here. So when I looked at this, I see this diff view between the left and right that tells me what happened, but it doesn't tell me why I did something. All right. So part of what I want to do in the comment is I want to say why I did this, right? And I added that comment in terms of the commit that I did, that kind of gives me the why piece, right? I fixed an error and I added new data. That's not a great comment. I'm trying to just go quickly, but the why becomes more of a business management coordination thing. The code comments are more about the complexities of the technology, right? Why did I do this Lambda this way? What does it actually mean for a structural thing? Okay, does it make sense?
Yeah, definitely that makes sense. And with that, I think it's time to go ahead and move to the next session, Steve. But it was really great to have you in the conference. Loved having you. And as Mahesh said, we would definitely love to host you again in some of the live shows and the events that we do.
Sure.
And, really looking forward for it. Thank you so much, Steve.
You're quite welcome. Thank you for having me, and have a great day. And hopefully we'll get a chance to work together.
Bye. Have a nice weekend.
All right. You too. Bye-bye.
Bye. All right. So with that, we move to our final session of 2 days, 24 hours SQL Server Virtual Conference by Tayob Ali, who's going to talk about a really important topic, that is Azure SQL Database Business Continuity During Disaster. So let's go ahead and invite our final speaker, Tayob Ali. Hi, Tayo. Welcome to the SQL Server Virtual Conference.
Well, thank you. Thank you. If I knew that introduction, I'd probably invite my mother-in-law. She's staying with us for a few days. And thank you. That was great.
Oh my goodness, definitely they need introduction time and again. Oh my goodness, and I'm really excited. Thank you so much for accepting the invitation for this conference. I'm really excited to go ahead and what you have to talk about disaster management, which is very important. And I have your slides shared, so I'm going to put that on the stream. So next 45 minutes, or you can even extend, it's all yours. Can you hear me?
Yes, I can.
Okay, perfect. So you can go ahead and start your session.
Okay, great. Great. Just want to make sure that let me take this over there. Okay, so thank you everyone for, oh no, that's a mistake. Okay, thank you everyone for joining. One thing, I want to thank the organizers for, for arranging this. And if you do not know, those of you are listening, you can also donate a little bit, any amount you want to this for the cause. This money goes to feeding some small children. They live in the slum. So you'll be surprised that how much it can do, with your small contribution. Like if you do a $10, I was reading, it can feed small children for almost a month. And they actually have a package. I think it's $39 or $40. They actually even send you a couple of gifts, which is not probably the reason for donate, but what the organizers did is amazing, right? I speak a lot of conferences, for different reasons, but this one is something really, with everything going on in the world, that we can, make some change. A little bit of our contribution can make a change. So let's move on. We really do not have, about 40 minutes. So one thing I want to make clear that I have all of these things in demo, but if I'm sure we run out because this is a 75-minute session. I compressed it to 50. Now I only have 40 minutes. So everything is already loaded into my GitHub repo. I just refreshed it like a half an hour ago. So if I do not get through the full demo, I'll give you my contact. Please reach out to me. I put enough comments that you should be able to run through those. And if you have to change any variables, any values, I made enough note there. And if you run into any issues, please reach out to me, and I'll make sure that I'll work with you one-on-one to get you through the demo. So I'm not going to talk more about myself. That intro video was enough. But please take a note of my contacts on the left side. You can contact me my Twitter, LinkedIn. My website has a contact page. Everything works. So just reach out to me. So why I picked up this topic? This is a real life scenario, true, that happened in one of the Microsoft data center in January 2019. 16 hour 11 minutes. Some of the databases are down. So ask yourself this question: that how many of you who are running some resources in Azure, and our talk is primarily on Azure SQL database, but even if you're running Azure SQL on VM, hyperscale Azure SQL managed instance, ask yourself this question: can you afford a downtime of 16 hour 11 minutes? Now, if the answer is no, then this talk is for you. And you might not have a resource today, right? Your company is probably prepping up. You're looking, down the road to move some of your resources from on-prem to cloud. Can be for many reasons, right? I don't know. It's depending on your business. Or if you're consulting, you definitely want to know this. So There are two terms that we always talk about, and I'm not going to go into details. RTO, RPO. Anytime you talk about business continuity, disaster recovery, I would highly encourage you to agree on these two times with your business owners before you really come up with a solution. Because unless you know exactly those times, your solution doesn't make any sense. Because as a data professional, it's not our job to decide those two times, right? Those depend on the business owners and how much money they want to afford or how much money they're willing to spend to implement those. Because as you reduce this time, you have to spend more money. And it's true on-prem. It's also true in cloud. And you will see as we go further. Now, there's a new term called ERT, estimated recovery time. You want to get comfortable with this term also, ERT. And ERT is basically, we're talking about your maximum ERT is RTO. And why I say maximum ERT, because your estimated recovery time will vary. Because now, before you are on-prem, so you have control on many things, right? How you set up your stuff, with your ISP providers and other stuff. But in cloud, you're kind of dependent on some of the SLAs that Microsoft is, dictating for you, right? So you need to let your business owners know about those and then make a decision. So this is, if some of you are new to these terms, I just put a graph just for you to visualize what I mean by RPO, RTO. And I'm not going to spend time on this one. You can, look at this later on. Now, this slide is really not directly related to our topic that we're going to talk about. But all the features that I'm going to talk about, everything is not available in every SKU that you deploy your Azure SQL database. So as you see at the top is a DTU and vCore. Those are your purchase model. And then you have your service tier, basic, standard, premium, general purpose, and all those. You have your compute tier because you can have provisioned or you can have serverless. And under those, even you have some hardware type. You have Gen 5, DC series, M series. And again, I'm not going to talk about those in details. You can go and read about those. But just so you know that some of the features that I'll talk about, you might not see in some of the SKUs because Microsoft decided not to have those available in every SKU. Just so you know. Now, I mentioned about D2 and vCore. I want to just briefly mention this. Microsoft's recommended model is vCore. D2 was released first, and D2 means database transaction unit. It's an abstract unit where your compute, storage, IO, everything is combined, right? So, and you call it a DTU. But when you go to vCore model, those are not abstract. So you can know exactly how many CPUs you are getting. You know how much memory you are getting and what the IO throughput based on the on the storage you are getting. You have a guaranteed SLA on all those things. And please pop your questions on the chat. I'm watching it. Also, Simon can stop me anytime because the goal is not to rush through this. The goal for you to get something out of this talk. So if I'm going too fast or if something not clear, please put your questions there in the chat. So these are some of the features that are available for us in Azure SQL Database to do some of the recovery during a disaster, high availability, or if you lost some data or someone made a mistake, you want to roll back, right? So temporal tables enable you to restore row versions from any point in time. Now, it's all configurable. I'm not going to go into details, and this feature also available on premise. So this is nothing exclusive to Azure SQL Database, but I still wanted to mention it. Automated backup is a totally new concept because whenever we used to set up a SQL Server and a SQL Database, we had to set up our backup solution, right? But here we do not have to do anything, but still you need to know, because there are certain things you need to configure. For example, how many days of point in time backups you want to keep, and also about your long-term retention. So I will talk about those. As soon as you deploy a Azure SQL database, you automatically get some built-in HADR solution comes with it, and it varies depending on which SQ you are deploying. It will vary what you get, and we'll talk about those. There's also zone redundancy. So if your database is just living in a zone, so in Azure they have multiple zones right now. Just to give an example, where I live, East US is a region, East US 2 is a region, and I'm sure wherever you are from the world, you're probably familiar with other regions. But within a region, there are also multiple data centers. So there's something called zone redundant, means you still, you'll still have an issue if there is an issue across the zone. But if one of the data center within the zone have some issue, you can have zone redundancy. Means you can have independent, cooling, compute, power, and all those, within the data center. So, and I will talk about this. Active geo replication is something, that similar to using always on availability group feature that we are used to on premise. So now you get zone redundancy. So you can have, data flowing from one zone to another zone, and it's keeping in sync with asynchronous though. And then you have auto failover group, because active geo replication is set up as a database level. But if you do have multiple databases that you want to fail over at the same time because of the application consistency with your database, you can create failover groups. So this is pretty similar to what we have on premise today, always on availability group. So exactly same thing. You can group multiple databases. So these are a couple of things, and I'll probably talk about 4 of those today. No, 5. I'll just skip the temporal table. This is what I was talking about at the beginning, that you need to know these times, right? This RTO and RPO, and I'm not going to read the slide. I just want you to know, before you you propose a solution, you go to the business owners, you want to know these times and show them, hey, can your business tolerate a 12-hour of recovery time? If they say no, then you say, okay, just depending on the backups, is not available for you, so we need to look at something else. Can you sustain an hour of auto failover groups? No, then we probably have to do a manual failover. So you want to look at those, and some of these are going to cost you more money, as I said before, compared to other solutions. So let's talk about automated backup. As I said, as soon as you deploy Azure SQL database, behind the scene, Microsoft will start taking backups for you. I put a first bullet point, might be a surprising statement, like, right? Lose control of precise RPO. Why do I say that? When I have a database on-premise, I can take a backup at exactly precise hour, minute, second that I want. I can have a precise interval for my transaction log backup if my database is in a full recovery model. In cloud, for Azure SQL, you do not have a control on on recovery model. Everything is on full recovery because that's how Microsoft can guarantee your SLA that they are providing us. Now, how frequently is based on the performance level and an amount of the database activity, right? Now, why do I say that you lose control of precise RPO? If you read this statement and copy it from Microsoft documentation or books online, we used to call, it says generally created every 12 hours, generally created every 5-10 minutes. And that word that generally means, it's not a precise time that I can control or you can control, right? So that goes away. Again, it's the same concept that I'm saying. It's not precise, right? It depending on between 5 and 10 minutes. So you just want to be aware of that. Your point in time backup retention, it's by default is 7 days. You can increase up to 35 days. Again, you'll be paying more, except if you are in a basic tier, you cannot increase it. It's only up to 7 days. Every other tier, you can go up to 35 days. There's long-term retention. So, I work for an investment management firm. keeping a 35 days point in time is not enough. In US, they call it Security Exchange Commission. They can come and tell us that, hey, we want to check that trade from 3 years ago, right? So either I have to keep this database data in my database, or I have to fetch it from a backup. So Microsoft allow you to put your backups for up to 10 years. And they are also geo-redundant, means they automatically get copied to another zone. So if the whole East US to go down or everything gets destroyed, your backup is still saved in a different region. Mahesh has a question. How does automatic backup impact the cost if you have a large database? Do you need separate storage for backup? No, you do not need to provision any storage or anything. Doesn't matter how big is your database. You only save what you want. Behind the scene, Microsoft will go and assign resources whatever you need. Like I said, as soon as you deploy, doesn't matter how big it is, you automatically get 7 days point in time backup. Means your full diff and all your transaction logs will be saved for 7 days. You can slide that. We'll see it in the demo up to 35 days. And then you can go and set up your long-term retention for up to 10 years. Of course, anything beyond the default, you're going to pay for it based on your size. And, like you said, you have a big database, but you do not need to go and fetch storage or have a storage account and all that. Microsoft will do that for you. I'm not going to read this slide, but I put it for your info because you can have many different kind of combinations or permutation and combination for your long-term retention. Someone might say, I want to keep my every weekly backup. Someone might say, no, I just need the first, I just need my monthly backups to keep for, and someone might say, no, for my business, I just need the, my 16th weekly backup keep for 10 years. So you have all these combinations you can do. These are a couple of examples that you can go through and you can set this up. And, if we have time, we'll see this in the demo. What you can do with your backups. As I said, you can do point in time, or you can bring your long-term retention backups, and you can also go to a different region and you can restore it there. So a new database on the same logical server in a different server in a different region. One thing you cannot do, and it's obvious, it's also same as on-prem, give you a real-life example. Had a deployment, and Steve was talking about, why source control, CI/CD pipeline, why not deploy manually, right? Steve was just talking before me. And this is, again, important that, a deployment issue, right? They did something mistake by, deployed some wrong code. They come and say, hey, deployed something at 5:25 Eastern time. Can we go back to 5:15, right? Now, they want the same server because they don't want to change the connection string, all that. So what's your option? You go and rename the existing database, and then you deploy, you restore it with the, with the original name. And once they're happy, you drop the old one. You cannot have the two databases with the same name, which is obvious. As I said, you cannot avoid an existing one. One thing you remember, if you delete a database, so like you have 7 days, right? Point in time. I delete a database right now. I still have 7 days to recover the database because my backup is there. Now, or if I have a long-term, backup. But if you delete a server, you cannot restore, you cannot recover a database. So just to keep that in mind. This is a question I get a lot. Can we restore on-prem? Not directly, but there are other options. I just put this. Please go and take a look. If you Google this, you will find solution. If you need help with any particular one, reach out to me and I can give you more details. Built-in HADR. So this is, and we'll see it in action. This is just deploying a Azure SQL database without doing anything. In this 3-tier basic, standard, and general purpose, what happened is pretty much, if you know what is a failover cluster instance, because you have one set of storage, but you have multiple compute. So this is the same thing. You get spare node capacity within the same region, maybe in a different data center, but you have data and log files that get replicated, and you have, if you see in this picture on the right side, Azure Premium Storage, local redundant, and your backup are always geo redundant. Now, if something happened to the active one, to the primary replica, what it will do, it will reserve a compute from another host, and then it will attach those data and log files, and you are in the business. This is a little bit slow because you are paying less compared to premium and business critical. Premium and business critical, it's modeled on, based on always an availability group. So your data and log file actually have multiple copies. So you have 4 copies of each of your data file and log file, right? And again, your backup files are same as we are talking about. Now with this, what happened is, before you get a acknowledgement back when you make a call to SQL Server, at least one of those secondaries must sync before you get the commit. So as soon as you have a problem with your primary, it just failing over to the secondary that's already in sync, and you're in business. So you all get this by default, right? Also, you have a read scale out from these replicas. Means you can send out your read-only traffic to the secondaries without paying any extra. If you are into the business and premium and business critical tier. I know read-only feature is nothing to do with your high availability solution that you're talking about, but I still want to mention this, that you can take advantage of it. Zone redundancy, I talked about it a little bit briefly. So this is within a region, independent power cooling network. Again, this is, let's move to the next slide. It'll make more sense. In general purpose, this is still in public preview. I want you to take a note. For general purpose, if you want to turn this feature, you have to turn it on yourself, and you're going to be paying additional cost. Also within general purpose, if you go back to my first, the third or fourth slide, I showed that you can get different kind of hardwares. You only get this if you get Gen 5 compute. So keep that in mind. Compared to that, if you're in premium and business critical, you're not paying anything extra for this. This comes with automatically for you. Now, again, only in Gen 5, you can turn this off. It's up to you. Because as soon as you turn it on, keep that in mind that your network latency will increase, because now it's going to do a synchronous replication to keep everything in sync. So you have to be careful with this. It is not available in managed instance. Again, if I know I'm primarily talking about Azure SQL database, but people are using managed instance a lot. Alvaro, you asked a question, are backups verifying? If I have to take a guess, and I'm taking a pure guess, I'll say yes. But if you do not, if you please send me a note, because I do not have your contact, I will research and I'll make sure that I confirm you. But if I'm putting my money now, I'll put it answer as a yes, that Microsoft will be verifying the backups. Active geo replication. So again, it's leveraging always an availability group. There are a couple of things that I want to mention here. You get up to 4 secondaries in different region. Your secondaries can be used for read-only traffic, and they can be behind. Just keep that in mind, because they are asynchronous replication, right? But they're transactionally consistent. So what does that mean? So I'm sending my read-only traffic, say to one of the hosts. I got disconnected, I reconnect again, and I did not get reconnected to that one because that one had an issue, right? Now I got my read-only traffic is going to one of the other of those 4 secondary nodes. Now the other one might be a little bit more behind. So I might not see that same transaction, but I would not see a half-baked transactions, that's guaranteed. Now, you might say that, I'm losing my hair for data loss, right? So as a good steward of data, you are worried about your data, right? So even though this is set up this way, now you have an important transaction that you definitely want to make sure that it is in sync to the secondaries before you send the acknowledgement. So you can use this with your transaction to guarantee that. But remember, it comes with a caveat, right? Because now you are forcing the synchronization. So it's going to impact your performance because it blocks the calling thread unless all committed transactions are replicated. So keep that in mind. You have to use it carefully, but you can use it. And if you go to books online, in Microsoft documentation, there are detailed examples how you can use it. Auto failover groups. So as I said before, we talked about let me go back a little bit. Active georeplication. Active georeplication is still at a database level. Now, if you have a couple of databases sitting in Azure SQL Server, which is a logical concept, that you always want to make sure that they are failing over at the same time, then you can create auto failover groups. But a condition that your databases still have to get replicated to a different region or a different server, and then you can set up auto failover groups. Again, this picture kind of gives you a visual how it works. One good point is you get two connection strings. As soon as you set this up, you get one for your read-write traffic, and you get one for your read-only traffic. And when you fail over or fail back, you do not have to change your connection strings. Your listener endpoints remain unchanged, which is pretty nice. But you cannot set failover groups. When you set it up, you can only set it up between 2 servers, whereas your active georeplication you can set up to 4. So just keep that in mind. And I have a slide next to this. This is showing you that you get 2 endpoints, right? So your connection string is actually based on your failover group name. So your connection string has no concept what's your host name or your database name, server name. Sorry, your database name, not your server name. So you just put your failover group name. So whichever is a primary, it will automatically detect and it will go there. So you are doing failover, failback, and no change on your connection strings. This is a chart that I think will be helpful because there are a bunch of differences. I wouldn't say differences. I would say like feature parities, right? Between auto failover groups and georeplication. So I created this small chart just so you know what you get and what you don't get with each one. And I'm not going to read this. This will come with a slide deck. Also, it's in my GitHub repo. You can download. We talked about a lot of asynchronous replication. So this is sometimes you might get a question if you're processing huge amount of data and people have applications that are reading from the secondaries, right? I have at my current workplace, because it's an investment management firm, we crunch terabytes of data, right, to give insight for our portfolio managers what to buy, what to sell, what to do, what not to do, right? So they are looking at all kind of stuff. Giving an example, right? US had election a few days ago, and so they go back and look at all previous elections, right? Okay, if this scenario, this party wins, what happened to stock market and what not? Now, in doing those, they'll have a lot of things. They just do it on the read-only replicas. But if you have a huge amount of data you are processing on the read-write, they might be all backed up, right? And they always looking at a bit. If that bit they can see it change from 0 to 1 on the read only side, then they submit their query because they know that it's still behind. So if you want to know, this is a T-SQL that I think I just copied it from books online that can give you some status like how far your secondaries are back or your read-only replica is back from your primary. So that's it. I kind of rushed through it. So I still have 14 minutes. It's a good position to be in. So I want to show you a couple of things in action that I talked about. And before I go there, I put a bunch of resources. These are all hyperlinks. I know this is a big topic. You read through those. Again, take a note of my contact And again, I know I'm rushing through, and so please reach out to me if you need help. So let me push my. So some of you may be wondering, I had this demo previously totally on PowerShell, and I used to use Visual Studio Code. So I switched it to a notebook, which is in Azure Data Studio. If you are not familiar with notebook, do not get hung up with this, like, oh, what I'm going to do with these demo scripts. What a notebook gives me is I can put comments, URLs, my code, and the result, and I can save it, right? That's the beauty. So if you do not like it, you can just copy these things and run it. You still don't like it, you just want to get a PowerShell version, let me know. I will get that to you. So in the interest of time, I already set up a bunch of things. So I ran all this already. As you can see, the output is there. I just ran it like 2 hours ago, just so you do not have to sit and watch. And I have a bold statement where the demo starts. So demo starts here. Now, it will not be fair to show you this demo unless I show you, what I did with this demo code, right? So I created a resource group. You always create a resource group. That saves you a lot of pain when you go to delete, because after this demo, I'm going to delete everything because I do not want to pay the money that I don't need to. I created 3 Azure SQL Server. In Azure SQL, this is not a quote-unquote server that we know on premise. These are just shells. And one is a primary and secondary to show you active geo application. In my secondary server, there is no database. It's just a shell sitting there. We'll use it later on. As you can see, there's no resource. In my primary server, I do have a database that is a sample from AdventureWorks. We're going to use this to set up geo application. I also have a Redis out. I just want to show you that if you see that I put it in a business critical tier. I don't know if I have oh, good. So I didn't realize that, this is too small. So as you see, this is in business critical. That way I can show you that the Redis feature is built in and comes with it. Okay. So this is what was created from this demo script. So let's look at a few things. Hopefully, great. Now I say that the long-term retention, the point in time comes built in, right? I mentioned that a few times. As you see that, if you see my demo code, there's nowhere I set up any backup. I only deployed this database, right? And if we go to backup retention now, it's 7 days, right? I know it's too small probably. So it's 7 days. And if you go to this drop down, as I said, you can slide it up to 35 days. Make sense? Now there is no long-term retention setup. And we can look at this, right? I can run this, and all I'm saying, give me the long-term retention for this database, and it says, everything is 0. Now I'm setting up, and what I'm setting up, I'm saying my weekly retentions for 12 weeks. So rolling, keep my weekly backups for 12 weeks. But if it's the 16th week of the year, keep it for 5 years. Why I choose this, I don't know, just for demo purpose. You talk to your business owners, talk to your legal, whatever they need, set it up that way, right? Now, once this is running, let's go back to portal again. we should see that now here, as you can see here. So let's go here. Right? Weekly backups, 12, 16th week, 5 year. And I did not provision any storage, nothing. Azure is going to, Microsoft is going to do it for me. I do not have to do anything. I can see these policies. If you don't like GUI, you can run this. I'm not going to run it, just trying to save some time. If you want to remove it, you can run this. This is going to remove your long-term retention. Now I talked about built-in HADR. As you saw there, on my primary database, I only had one database, right? I did not set up any active geo application or anything. So if you have watched, who was talking about Ostress? I think Frank, I don't remember, Frank or Tracy was showing Ostress. I think Frank was showing Ostress 2 sessions ago. So this is a tool. So what I'm going to do, I'm just going to, connect to my primary server and just do a select, right? Nothing fancy here. And then we'll do a failover. It's going to ask me for my password because I didn't want to put it in the script. So, and then you'll see that, it's doing a select, right? Now, I'm invoking a failover. And I do not see a second server or anything in the portal. Now, this one is going to take a little bit longer time because this is not a, as you see that we are getting failure now, right? Because it says it's not available. And then you'll see that it will connect and start running my select statements again. Now, this is not in a premium tier, as you see that, right? It's done. It's failed over, automatic. I did not deploy anything. If you do this in the business critical tier, you will see that this will happen a lot faster. And I know that I'm not going to, run this for, just for saving some time. Now, on the primary server, I'm setting up an active geo application to the secondary server. And I put my database name. These are all variable driven. So you just do it at the top, and then you don't have to mention this again. So let's run this. Now, while this is setting up, let's go and try to see what's happening on the portal. We are setting this up for this database, right? You should see that right here, So it's good that we caught it in the, oh, no. It's sitting right now, right? So it's sending the whole database to the central US, to my secondary server, and with the same database name, right? It created the database and syncing it. Once this is done, we can do a planned failover. So this is done right now. Now we are failing over to the secondary. So let's go to portal. And we should see that our primary and secondary server name should be reversed. I mean, I know the commands work. It's just, some of you might not be familiar with this, so I'm still showing you this. So as you can see, right, you notice that it flipped. Now the primary is in central US, even, as you see the server name, and my secondary is in the primary server. The command hasn't finished yet, but we could see it over there. It just, okay. I'm just going to fail back for the next demo. Simon, should we continue or try to wrap up? You tell me. Because it's 5:48, I don't want to, overstep the times that you have. Okay. So look at a failover group, unless I hear from Simon.
Dai, we can continue for 5 or more minutes. It's okay.
Okay, great. Okay, thanks. Yeah, 5 minutes should do it. So failover group, you can create a failover group, but not have any database. You do not have to have a database when you create a failover group. So let's create a failover group. It's empty, and let's go and look at it. And whenever you're looking at a failover group, we won't be looking at it from a database level, right? We need to look at it from a server level, because we can bundle bunch of databases. So as you see, we just created it, failover group, that's the name. And right now we do not have any database. Right? Database count 0 of 1 means you have one database that's eligible, but you do not have one right now. That's all it is saying to us. Now we're going to add this database into our failover group. And if we refresh this, as you can see here, and I'm supposed to, in my notes, I say to myself, we can go and connect to this, and I can show you the server name, but just in the interest of time, I'm not going to do that. So this one will relate to primary, and secondary.database.windows.net will, oops, sorry, I shouldn't have, it will just, connect to this. It's obvious. And we can do a failover. We can do a force failover. We can remove database, add database, everything from GUI. But just to keep it consistent, I'm just going to use this. So now we are, doing a failover, and we should be able to see it here. It did not, so it's still taking some time. Yeah, it's done. As you see now, right? And the beauty of this is, like, as I said a few times, your connection string, you do not have to do anything. And if you want to know in your failover group, who is sitting where, what's the status, you can just, this command is not doing anything, just get, it's a get command. It will tell you, what is my failover group, what database, where is my primary, where is my secondary, and all that. So I'm just going to leave this here. The last thing quickly I want to show you, the read scale out, right? And if you remember, we have this one database in the portal. I named it, obviously, with read scale out server. This is not a part of any failover group. We haven't set up any Active Geo application or anything with this one, right? Just standalone. But even with the standalone, I get multiple copies, and I have read-only servers that I can send my read-only traffic. Just to prove my point, I want to make sure Windows.net, SQL. So if I use this, yeah, now I have to really connect to this again. And we should go to the database, this one, connect. Now here I did not say my, again it's read only, so I probably have this saved. So let me show you this something. Anyway, so if you have this turned on, read only, it will take you to a secondary server in your connection string. If you are in those tiers, you automatically get this. And if you do not have this mentioned, or you can have read write, but it's by default read write, it will take you to the to your read write node. So that's all I have. I'm going to get back to my slide again. Oops, it's probably switched the displays. Okay. So I thank you everyone, for attending. I know it was a long day for some of you, especially of course for the organizers. It's a 2-day last session, but I'm really honored, humbled. I know that I can join this cause. Again, I'll thank you again. I'll leave my contact pages to any of you have questions, comments, and maybe I can just quickly show you probably my GitHub page if anybody's interested. Yep, so if you go there, like I refreshed it 2 hours ago, please download anything you want, and send me your questions, comments. Thanks again.
Thanks, Tayo. It was a great session, very detailed and great insight you have shared with some demos and all. So definitely a great session. Definitely get to learn a lot. And for guys who have joined live and for the guys who will watch later on when the session is archived. And there we have Mahesh. And hi, Mahesh, how are you? You're muted, as always. You're muted. Oh my goodness, you are muted.
Yeah, hey. I just want to jump in before Tayyab leaves. I just want to thank him personally for all the support and help he's been doing. This has been a great help from you, Tayyab, as well as some of our Microsoft friends. We have Anna, Bob, Buck, Julie, and Tayyab. They have helped us a lot. Otherwise, this won't be possible here.
Oh, thank you. Thank you for inviting me for the second time. I work with Julie a lot on the data studio. I know Anna, Bob is speaking in one of my group that I run virtually. So it's a teamwork, but I just like the cause that you guys did. As I mentioned a few times, I also tweeted that, a little bit of our contribution, because this is a cause that I haven't, there was one for the MVPs we did for earthquake in East Europe a few days ago. But doing it for children, especially those children, it's something definitely. I'm really thankful that you guys are doing it, and then we can do very little and make impact, right? So this is something I think we should try to do more.
Yeah, obviously some of us are lucky, and again, Simon is here. I'm here. Anytime we can help you. In any of your groups, you're doing any events, we can help you promote, partner, anything. This community is for you, right? This community is all about helping everybody.
Exactly.
So even though it's a C#, we call it C# corner, but now it's just everybody joins it. So anything we can do from community side, just let us know. and we are here.
Sure, especially with past ceasing the operation, we are a little bit in a panic mode for a few weeks. I think, Steve was here before. Steve and bunch of leaders, they're really stepping up and, filling that void. And Redgate just declared something amazing 2 days ago. I'm looking forward what comes out of it. So yeah, it's all again, it's working as a team and helping the community. I think what you said, I absolutely agree. So I'll go offline. I'll let you guys do your, the final talk. Good luck and looking forward to the next one.
Thank you.
So much.
All right, Simon. So here we are, 2 days. You're still going strong. Looks like you're still awake. It's what time is like 4 a.m. in India?
It's 4:30 a.m.
Yeah, 4:30 a.m. and you're still going strong 2 days in a row.
I think
you want to bring David in the show as well?
Yeah, definitely. I'll add David now. Hi, David.
Hey, David.
Hey, everybody. How's it going?
There you are. Hey, so yeah, I mean, I want to thank everybody. I think all audience, they were very patient during those 48 hours, pretty much kind of. We had a lot of audience joined in. We kind of probably peaked the traffic a lot today, and we will have more stats. But I think, Simon, you gave me numbers. We have about 20,000 people join in or more.
Wow.
Entire this show, before both days. And I think we have 27 speakers. They're all great guys and girls. They were all great, amazing speakers. I mean, I learned so much myself during last 2 days. So Simon, anything else you want to add before we go to the next topic?
Yeah, I mean, I was just looking at the comments, and that people really loved all the speakers. The first day was more about all the new tools that Microsoft team has brought in the Azure SQL space. We did talk about Azure Data Studio. We did talk about SQL solutions, which is pretty new. Program managers coming in, sharing the insights that are not been even there out, even in the community and even in the internal. So day one was great. Day two, we had guys who have been working on SQL for a very long time, 20 years, and they come and share the best practices. So 2 days, wonderful. I'm gonna join as a DBA very soon in another company.
Well, you just had we could be a great help for you. But no, we had a great keynote, and I learned a lot what direction this Microsoft is going, and how SQL, Azure SQL, and everything is going. Looks like this is going to be the most intelligent database ever, because the whole AI and Azure in the background and power of whole thing. So that was great.
Yeah.
We learn a lot from that. So, okay. So next topic is obviously, as many of you know, that we are doing this conference for the cause. And this last year and this year has been, pretty bad for especially, poor and children. And I was looking at the numbers so far. Already 88 million people have already fallen into extreme poverty during this pandemic. And they are, by 2021, end of 2021, it's going to be 150 million. So 150 million people will go to extreme poverty. That means they may not even have food every day, twice a day. They may, even in the US, forget the other part of the country. I was looking at the situation in the US. I think there's about 11 million parents. They are only eating once so their kids can have food twice a day. This is just crazy. Yeah. So David, what our goal is that we are going to have these 21 conferences this year. And each conference, we're trying to help one NGO that's focusing on children and poor.
Yeah, that's a great idea. Yeah. And I'm really, before I forget, I just want to really thank C# Corner and you, Mahesh, for doing this for the Voice of SLUM, because, that's, really close to my heart. And I've been trying to help support the last year and a half. So I just want to put a shout out to you guys for doing this for the kids at the Voice of SLUM.
So yeah, we raised a couple of $1,000. Simon, you want to share some numbers? So this is Voice of SLUM. David, you and I went there with the Magnus.
Magnus, yep.
Yeah, Magnus, we went there. We met the founders. We like what these founders are doing themselves. They grew up from in slum. They grew up and they somehow got out and they started this NGO and they're doing this for great cause. And I know you were very emotional when we were there.
Yeah.
Want to tell people a little bit about that? A couple of more minutes.
Yeah. So when we went there in 2019, I have to say that going to the Voice of Slum in Delhi, in one of the slums in Delhi, was probably the most moving experience I've ever had, traveling the world, and I was trying to think about it this morning after you asked me to speak at the end here. And I was thinking, I think the only time that came close to this was back in my 20s when I was in the military and I got to visit the site where they dropped the bomb in Nagasaki. So there's a picture of me standing right where the bomb dropped in Nagasaki. And that was pretty moving, to me as a young, 20-something-year-old. And so, helping others that, really need it. And so the trip in 2019, we went there and, we got to meet Chandy and Dave, who really inspire me. And I said that in the video that, these two people that came from the slums, they were rag pickers, right? They had to leave school as a kid, not even a teenager, a kid, so they could help support their family at home,
Yeah.
and I know in America we talk about poverty and food insecurity and all that, but let me tell you, that's nothing compared to what I witnessed in Delhi,
Yep.
and
Yeah.
And so it was a completely moving experience to me. Like I said, at the end, I could barely talk, but during our time there, I got to learn a lot about the Voice of Slum. I got to learn about what their needs are, and that's why I've helped restart their vocational training. I got to meet some of the kids. That was really awesome. We got to hand out candy. We gave them big bags of school supplies. They were all really appreciative of that. And even, I didn't think this was going to happen, but even some of the kids that weren't utterly shy, stood up in front of us and sang a couple nursery rhymes, for us, which I thought that took a lot of guts. So, those of you out there that are afraid about speaking, try to get in front of a bunch of 6-foot geeks, at an orphanage in Delhi and see how terrifying that probably is. So, So and so anyway, I've been giving back to the Voice of Slum ever since I got back to America, and I'm also now, I have a new project I'm trying to get done, which is, last year I started something called the Hello World Cookbook. Actually, later in 2019, I think I did actually. And so right now, if you go to helloworldcookbook.com, you can go submit one of your food recipes, not code recipes, food recipes to the Voice of Slum, and to this website, and that gets sent to me, and I'm compiling them, to put out a cookbook of recipes from technical geeks just like you and me. And so it's going to feature, recipes from everybody from all around the world, all types of food and drink and whatever you want to do. And so please send them to the Hello World Cookbook so you can continue to help out the Voice of Slum, because 100% of the proceeds of this book will go to the Voice of Slum every month. So I know a lot of geeks out there, especially the male geeks in our crowd, don't like to cook very much. So there's other ways you can help out. You can be a unit tester, which is you get to test the recipes and let me know what you think, and so I can put in some reviews. You can also sign up to help me with the graphic arts, because I need help with that. And if you're good at English, which I'm not, you can help be an editor on the book too. So there's lots of ways to help, and I hope after this conference that you'll go to Hello World Cookbook and continue to help the Voice of Slum, because I'm definitely going to go back and visit them when I go back next year, hopefully. So.
Yep. And then we definitely, we would like to thank all the donors. We got a lot of donations. Simon, you want to share your picture, share how much we got to raise fund for this Voice of SLUM. So these are numbers. We are going to publish these numbers on the website as well. So I believe we total raise about $2,800. That was awesome. Good job. Thank you so much for everybody. We got even a lot of our speakers. They donated a ton of money. 20 people actually bought our community C# Corner community supporter package. So that was awesome. And we already donated this money. We already donated to Voice of SLUM about $2,278. Check was already given to them. We are going to also post this on C# Corner as well. And so from here, we are now going to announce next couple of our next conferences. And now we have picked another charity. This time it's in the US, and they are also they're also focusing on children. So more announcements will be coming there. So anybody who's watching us and you want to help donate, you want to become a speaker, or you want to, participate in different ways in the community, or you have a charity and they need you think of help in different countries. We're definitely looking for different countries because we have access to India, we have access to America, but we are also looking to help in other countries as well. So reach out to us because we're going to have again 21 conferences, and we want to target at least 21 different charities through this cause.
That's awesome. And that's awesome. You're going to do this for the rest of your conferences this year. So
yeah. So this whole year will be focused on these charities. And again, let's thank our sponsors. We also have a couple of sponsors who gave us $250 each, Redgate and SQLplus.net. They are awesome product and tool. Check them out. Mindcracker and MCN help us from resources perspective. MCN help us a lot of giving access to their resources. We are using their offices and so many other things. So thank you so much for all these sponsors helping us in this conference. Simon, anything else? I think that's my list here. I think I am done with my thanks. Anything else you want to add?
I would just like to go ahead and add the picture of all the speakers that we had, around 27 speakers with 26 sessions. Great diversity joining from Microsoft team, CEOs, CTOs, Microsoft MVPs. So thanks to all the speakers for all the time they have given. And a quick picture that we could get from the Voice of SLUM while we donated is that this is the picture of the entire team over there. And we have a few more. Kids look happy. And this is the one. And I think the one last one that I have is a video.
Yeah, and then
that's awesome.
That's great. That's great. Yeah, we'd love to go see these kids again, David. When we go back to this conference, hopefully, I don't know when. Hopefully this year later. If not, definitely next year.
You're making me all teary-eyed again and getting tears in my eyes just looking at those pictures.
Yeah, and in the end, we definitely let's thank you this team behind the scene. Simon, you have a big team working behind you. They've been
Simon
working
rocks.
non-stop. I know you guys on coffee and tea, and everybody's probably like not sleeping a lot. Thank you so much. You have those guys available, their names, teams. You want to thank everybody with the names?
They're not here, but I would like to give a shout out to Bhaskar, who helps us get together our entire team. Then we have Rohit and Manish, who manage the social media and digital marketing. We also had a new guy, Pradeep, who helped us manage the moderation for all the comments. And definitely we have guys volunteering from dev team, editor team. They all just join in whenever it is the time. So yeah. Really thankful to my team. I think I'm just lucky to sit in front of this camera, but I have a very passionate and a dedicated and a talented team who works behind the scenes. So yeah, that makes us successful. Yeah.
All right. So I think that concludes our conference. That was very good.
Can I
Great
say one
job,
thing real
everybody.
quick?
Yes, definitely, Dave.
I also want to give a shout out to you, Mahesh, for putting these on and, taking on the, I didn't know you guys were doing 21 conferences this year. So that's amazing, and so, thank you for, as a software developer, thank you for putting these on. I'm a software developer and a speaker. So, I'm just like everybody else out there. And while you were saying all this, I'm going to, I just thought of something I could do for when I come to India next year. And that is from the rest of the 20 conferences this year, if you donate a minimum $1 to each conference and show that to me when I am in India next year, I will give you something really, really cool. So it's only $20 out of your pocket for an entire year. And I will bring you something that you can only get from doing that. Okay.
That's awesome. That's awesome. And yeah, and then I think if you want to learn more about other conferences we are doing, the website is 202020.net. Maybe Simon, you want to put it there on the screen, where we have listed all, not all of them so far, but we have at least next couple of conferences coming up. They are listed there. But we're going to announce every month. We're going to have a big major conference like this one. It will, conferences will focus on different topics. There'll be full stack developer. There'll be Azure. They're going to be, Angular, React. And we did a software architecture conference last year that was very successful. We are also going to have again that speakers conference, how to become a professional speaker. So we're going to bring all those conferences back, which we did last year and more. So this is the website. You want to go check it out. The schedule's coming up. Or follow us on social media, C# Corner account and C# Live. We will be posting all these events live there as well. Yeah, this is going to be busy year for us. Listen, there's two ways to do it. Either we can sit quietly in pandemic and cry about it and complain about it, or we can figure this out, do a better way, and take advantage of the situation. That's what we're trying to do here. And David, you've been a big part of this whole thing. You taking the shows and you're helping us a lot. You're kind of already becoming part of the team. So, everybody's kind of adding whatever they can. So that's a great thing about this.
Yeah. Yeah. It looks like it's going to be a fun year. So that's awesome.
Yeah, it's going to be a fun year. So thank you so much, everybody, for joining us, and hopefully see you next conference. A good night and have a nice weekend and have a safe year in this 2021.
Bye,
see you, everybody.
Thank you. Thank you.